I can still see the attendees are coming in thick numbers right now. So just 2 more minutes. At 2:05 we'll start this session. Okay, without further ado, because we have a very power-packed agenda today for all of us, we'll get started and kick off the Kepware Discovery Day 2020. I'm your host for the day. I'm Prajwal. I represent the marketing for ATS India, Sarla Advantech, and Kepware for all of you today. Thank you for taking time out of your busy schedule and agreeing to invest 3 hours of your time during this journey. I'm sure this is going to be an exciting event for you. Each year we do the Kepware Discovery Day to share the knowledge that Kepware has accumulated over the years with all of you and help you make most out of your Kepware investments. This year, due to the ongoing situation, we had to move the event digital, but I'm sure next year we will have Steve with us here in India and we will have a wonderful face-to-face session. So the speakers for today, ladies and gentlemen, we have Nilesh, can we move to the next slide, please? So we have Steve with us, who is the senior application engineer. So Steve is joining us from Singapore. It's kind of early evening or late evening for Steve, but is making his time today for us. Thank you, Steve, for your time. We have Taranjeet Singh with us today. Thank you, Taranjeet. Taranjeet is one of our customers from Addverb. Addverb is using Kepware since 2018. They've made some big gains. They've realized some technical benefits using Kepware. So Taranjeet will today share his experience and the experience that Addverb has realized using Kepware products. We have Shinu, who is our sales leader for Sarla. He's joining us from our Bangalore office. I hope it's the Bangalore as I should call it, Shinu. Sorry, don't get offended. Don't get offended there. And we have Vivek joining us from our Ahmedabad office. So Vivek Chandpura is our automation delivery center head. Nilesh, who is joining us from our Mumbai office today, is going to be our host as well. So on the next slide, Nilesh, if you can move to the next slide, please. This is the agenda that we've packed in for today. We'll be starting off with an overview of the organization, a crisp introduction about how we have originated as an organization, where we are poised to grow, our association with Kepware, and then Steve will share updates about the latest Kepware drivers, Kepware releases that we have. Then we will have a short break where we will have questions coming in from you. If you have any questions to ask, you can pop them in the chat window that you have. And we cannot promise that we'll be answering all the questions, but we'll be trying to take as many questions as we can during the course of this event. And the answers that we are not able to provide, we will take them towards the end. So we have to make sure that we have ample discussions flowing. We have 2 question answer sessions, one towards the middle of the agenda and one towards the end. So I'm sure we have enough time to cover all your technical queries. Post the short break and question answer session for 10 minutes, we'll be moving over to the Kepware experience by Taranjeet. Taranjeet will share the journey that they've had with Kepware and what are the new prospects they see using Kepware's latest drivers and plugins. Then Nilesh will take us through the major drivers that Kepware has to offer. We move into the plugin section where Steve and Vivek will share information around the IoT data logger plugins and advanced tags. Then Steve from Kepware will again share his expertise on link master and redundancy master. Post that, we open the session for a Q&A, and then we expect to answer all your questions during that session as well. So you have 2 sessions wherein you can kick off your questions in. And I hope you enjoyed today's journey with us. So Nilesh, can we move to the next slide? So the first session would be presided by Shinu. Shinu, can you please take over?
Yeah, thank you, Prajal. I hope you can hear me. Hello?
Yes, Shinu, we can hear you loud and clear.
Yeah. Good afternoon, everyone. And thanks once again for attending the Kepware Discovery Day. Thanks, Steve and Taranjeet, for joining us today. I am Shinu Sakaria, and I will quickly run through a brief introduction on Sarla and what we do out there. Since most of you have partnered with us in a way, in one way or another, I am not going to take much of your time, and we can move on. Nilesh, next, please. Sarla Advantech. We are a proud team of over 450 of us. We are committed to delivering the best solutions in automation softwares, manufacturing integration, MES software development and testing. And we have been in this space for over 20 years now, delivering solutions across various manufacturing industries like pharma, energy, chemicals, metals, automotive, etc. With our close to around 15 plus offices across the globe, and completed around 2,500 plus projects, both in India and globally. Currently, we are now part of the ATS global group, who are again an independent solution provider for smart digital transformation for users worldwide, and provide products and services across all 3 levels of automation pyramid, which is your control layer, execution, and the information layer. Sarla has had a long-term partnership with leading solution providers like GE Digital, who are offering various automation softwares like iFix and Simplicity SCADA, Historian, WebSpace, etc. On SAP, on the MIA and the MES services and solutions, where I'm on MES services and OPC router and Bayshore with their cybersecurity solutions, and of course Kepware. Nilesh, you can move to the next slide, please. This is just a brief overview. So Kepware, the PTC company, was founded in 1995 and released the industrial leading server as you know it earlier in the year 1997, which was actually quickly adopted by manufacturers all over the world as an OPC server. And in 2016, PTC had acquired Kepware. And as per one of the surveys or on the ranking of a Fortune 500 annual ranking in 2016. Kepware active customers include close to 60% of top 100 companies in the world. And companies which are not on the list are not among our normal manufacturing customers. It's mostly in the banking, insurance, and the retail market. I think Steve can probably add in there and speak about it. And Nilesh, next, please. So Salla, we have been associated with Kepware for 9+ years now. And during this time, we have built a strong team of 30+ engineers who have shared their expertise and experience with over 400+ customers. Yeah, Nilesh, next. And with this partnership with Kepware, we have has led to a long-lasting association with many of our SIs and OEM. And I think Taranjeet is here joining us from Addverb. And we have also been able to complete many projects and gain trusted relationship with many of the major companies in India. So I think this is it from me. Probably we can move to the next thing. Thanks once again, everyone, for joining us. Steve.
Thank you, Shinu. That was insightful. Now we are moving over to Steve. Steve joins us as a Kepware as subject matter expert today. And Steve is going to take us through the Kep server's latest releases and updates. Steve, over to you.
Hello, everybody. Thank you again for joining us on this live webinar. So I'm Steve. I am the Senior Applications Engineer in Kepware. And I'm happy to be here to present to you to talk about this. So on this section, we're going to talk a little bit on the latest updates that we have for Kepware, right? Specifically the 6.9. So for those who are aware or have been using Kepware, you should know that every quarter or so we will release a new version. So this new version typically has new driver enhancements, security patches, and things like that. So today we're going to talk about the latest one, which is the 6.9. So this is actually what I have in terms of agenda, right? So I'm going to just update a little bit on Client Ace, which is one of our SDK products. And then we're going to talk about the server updates, followed by some of the driver updates. So just as a start, we have a product called Client Ace. And the Client Ace, we have intention to move it towards the end of life cycle. So as of September 6th this year, we have stopped selling the product itself. So if you have a Client Ace running with you and you have a support maintenance that is active, you will continue to be supported through our typical tech support channel or even our distributor, which is Sala, right? If you have any questions or things that you want to ask, you can also check out our FAQ sheet on Kepware.com. So the links are over there. And that's really what we have for Client Ace. So in terms of server updates, for 6.9, we have added a bunch of new tag counts, the ways to look at new tag counts. So for example, in the underscore system tags, we now have a underscore active tag count. So for those who are not familiar with the underscore system tags, for every device that you create in KEPServerEx, it comes with an underscore system tags. And each of these underscore system tags provide data about the health of the channel and some metadata about the channel. So today we added the underscore active tag count. So what it does is that it allows you to see how many tags are actually being pulled instead of the static tag counts. Then on the UI level, so if you open the configurator tab, you can see that we added a new column that says static tags, or rather a new row that says static tags. So that really is the new features that we have in terms of the server updates. The next major server update that we have is the adding of support of deletion of custom user and groups. So for users who are not aware, we actually have a way to do user management under the KEPServerEdmin. And inside there, you can actually create users. So prior to 6.9, what we typically do is that if you want to remove a user, the only thing you can do is that you can disable them and then you hide them. But from 6.9 onwards, we now have the capability to delete those users, so you can completely remove it from your user manager. The next thing that we added is in the administrator group. So the administrators now are able to, as long as you're in the administrator group, that means you have your user that is under the administrator group, you can now import and export the users. Okay, next we actually remove support for resetting administrative passwords over the command line. So you can no longer reset the admin passwords. And last but not least, descriptions are no longer visible in the user manager tab. Okay, they can only be viewed by editing the user or group properties. So if you look at the screen I have over here, this is actually part of the configuration API. So the support for the deletion of the custom users can now also be done programmatically using the delete method. Right, so that's the config API. And over here is a picture of how the user manager looks like. So again, you would go under the KEPServerEx tool, which is a small little icon at your system tray at the bottom right corner. If you right click settings, and then you will pop up this window and go under user manager. And that's really where you will see the different users. So you can see that I have a bunch of groups and these are the users. So now you can actually select the user and click this to delete it. And if you are part of the admin group, you can actually export the data out and import it into, maybe another Kepware, maybe you're doing a migration. So you can do all that right now. So next, we're going to talk about the driver updates. So as you can see, the driver updates are pretty comprehensive. I will not go through all of them, but for the ones in bold, those are the ones that we will talk about today, right, in the interest of time. So first, we have the FANUC FOCAS driver enhancement. Oops, I just realized I have a window. Okay, the FANUC FOCAS enhancement. So if the FANUC driver, if you're using the FOCAS Ethernet driver today, we have added the CNC RD axis data. So that allows you to see the machine position of the X, Y, Z axis. And on top of that, we added the CNC EXEPRG name, which is actually a tag that displays the program that is being executed. So you can see like what are the programs that is being executed by the CNC machine, or rather the FOCAS machine. And you can also see some of the RD axis data. And the last one would be quite interesting, is actually the CNC RD dynamic tool call. And what this tag in particular allows is that they actually expose some of the information such as alarms, position values, feed rate, spindle speed, sequence number, and program number. So in that sense, this enhancement will allow you to get more data from your CNC machine if you are using this driver today. Next, we have the OPC UA client driver. So if you're using a UA client driver, today we now enhanced on the support of importing and reading the OPC UA nodes. So you can see that there is a list that is being listed over here. So these are the some of the structured data type specified in OPC UA, and we actually support it right now. And if you look at this screen, this is how the data will look like if you pull out from the UA server that has data that looks like that. Right. The next thing that we did is that we added the ability to read value attributes with the extension objects of supported data type. We enhanced the support of reading additional members of the server complex data type object. So now you can actually pull out more information about the OPC UA server that you are connecting to, or rather, Kepware's OPC UA server. So for those who are not familiar, in OPC UA, each of the OPC UA server has a complex data type object that describes the capability, available methods, and certain parameters about the UA server. So that you as a UA client, when you connect to it, you're able to tune your UA client accordingly to meet the specification that is required by the UA server. Okay, last but not least, we fixed an issue where the interface will always report the value of elements in Boolean array as false. So this is actually one of the bigger enhancements that we have for OPC UA. Moving ahead, we plan to make the UA driver as comprehensive as possible. So you'll be seeing a lot of UA client development on Kepware's end. Next, we have the talk to. So for those who are using talk to, which is pretty rare, but we added support for reading and writing tightening programs from the PowerFocus 6000. So if you are using an Atlas Coco talk to, for example, these are the added devices that we have, and we actually added some of the Stanley QPM NUT Runner series as well. So if you are using a talk to or you're a talk to user today, we added some capability for you to connect to more of these tools. So if you want to see a complete changelog, there was like a deck which we showed like all the different drivers update. Please visit the web link that I'm showing here, the release note web link. So from there, you can actually have a complete changelog of all the drivers that we have, which version that it came out, and some of the bug fix that we list on over there. So it'll be a pretty comprehensive changelog. So the next section I'm going to talk about, as a way to finish the session on the product updates, is to kind of provide some of the forward-looking information. So just be aware that the forward-looking information that I'm going to show right now are subjected to changes, right? So it's not a finalized thing, but I just wanted to share with you guys some of the forward-looking stuff that we will be releasing. So in 6.9, which is under the last release, pretty much we focus primarily on the security stuff, driver maintenance, all the different drivers that we fix, and the UA client driver enhancement, right? The complex, the structured data type that we support that we talk about. And for TKS, which is the ThingWorx Kepware server, we added Active Directory integration. So the TKS is actually the subscription version of Kepware, so it's just a different branding, but the AD integration is over there. For the next release, which is the upcoming 6.10 release, we are looking at one of the most important things, the UDD driver. So the UDD driver is also known as the Universal Device Driver. So the Universal Device Driver is a very long name, allows you to do scripting in order to pass out custom protocol. So if today you are a user of UConn, you might be familiar with somewhat the concept, just that instead of the transaction editor, which is UI-based, the UI-based design, we now have a more flexible scripting kind of environment for you to take in data and pass it out, accordingly. So it's more flexible in a sense. Then for Yokogawa, we are going to release the GX driver, which allows you to connect to the GX devices. And last but not least, the Siemens TIA Porter exporter version 16. Right. Then on the TKE, which is the ThingWorx Kepware Edge, we are going to have an initial container offering. So for those who are not familiar with the TKE, which is the ThingWorx Kepware Edge, it is the Linux offering of KEPServerEx, which was released somewhere this year. So now we are at 1.1 and we are heading towards 1.2. So that's really the most of the stuff that we're going to talk about in the next session of my presentation. So in the future, these are some of the key things that we will be looking at. In particular, the license server support, which allows you to kind of manage the TKE's license. So you can actually manage it through a single software, as a server, and then you can manage it properly. We are going to also look into the OPC UA gateway, which is part of our commitment to OPC UA, with additional features like enhanced tunneling, browse through function, further complex data type, and meta support. In terms of enterprise management, we are also looking to have a way to interact with the license server that will enable easier way of provision, as well as some server health monitoring and multi-instance configuration. And last but not least, for the TKE, we are looking to add in further enhancement to support additional OS, ARM support, and as well as a better Docker support as well. So these are some of our future development, which is typically in the next year or so, and features like that. And that's really the end of the first section, right? So as a reminder, if you have any questions, feel free to type into the Q&A box. I am going to go into the next section, which is the ThingWorx Kepware Edge overview. Okay, so when we started the TKE, which is the ThingWorx Kepware Edge development, we actually worked with a couple of system integrators and identified some of the challenges that they encounter. So the first problem is the demand for digital. So as engineers who are in the industry, you should know that there's like a wave of IoT or interconnected devices coming along, And what that really means for OT engineers is that there's a new demand where we need to connect the machines to new platforms that we have never done before, right? And on top of that, for machine builders, there's a demand for smart machines. So customers are looking and asking whether the machines can be connected, can be monitored remotely, can they have some onboard alarm functions and things like that. So those are all putting up increasing the demand for digital or digitization. So as mentioned earlier on, because of this whole movement, there is an increase in need of connectivity to various cloud platforms, right? Cloud platforms as well as IT-centric systems. So for some of your customers, they have an IT department and they want to embark on digitization. So instead of cloud services, they may develop their own on-prem protocols, and usually these are pretty IT-centric rather than OT-centric, right? And last but not least, when we do all this, right, we cannot forget our traditional OT requirement where we still need to connect and display the data on the HMI. So these are all some of the new things that a lot of the machine builders and SIs are encountering when they see when we talk to them on this. And last but not least, the lack of talent. So the problem with all these things is that you require a certain pool or rather a certain type of software developer in order to kind of build out a connectivity that can connect to OT and connect to the IT side, right? So it's kind of a niche market. So for some of the system integrators, they feel that the problem really is that they cannot find people who are able to do this. And most of the machine builders and system integrators that we talk to ended up with a DIY kind of connectivity platform. So they may have engaged a third party to develop it, or they could get an SDK from a couple of brands and they patch it up and created some sort of solution. And these are some of the problems that the 4 key problems that when they decided to go with the DIY method, the do-it-yourself method. Okay, so the first problem, right, is that in software development, right, if you choose to have a customer or you're going to build up some connectivity system, this may take you months or years in the development, right? So you have to, maybe take about a month or so to scope up the scope of work, maybe an MVP, if you're into that. Then you have to iteratively keep doing a couple of POCs, a couple of development drivers, builds, alpha build, and so forth. And finally, you do a test and then you do a deployment. So that can take you years, right? And if on the other hand, let's say you have a product that is commercial off the shelf, you can actually download it, test it out, and then you configure it, administer the license, and you're done, right? So you are reducing the go-to market time in terms of developing the connectivity layer. So the next problem is that even if you have done the DIY portion, you have completed the whole thing, there will always be software bugs or even security breaches. So you have to maintain it. You have to have a team to maintain the codes, right? It's not a one-time thing. So that's going to be another challenge for some of our customers. For example, halfway through the project, the engineer leaves the company and then they couldn't find anybody to come in to take over and things like that, or handover issues where the code base were not synchronized and they were out of date or things like that. So compared to, say, you have a vendor who provides a commercial off-the-shelf solution, and all you have to do is really just to download it and just do an upgrade. So that would actually again shrink down the time for you to go to market with a proper like off-the-shelf solution out there. Okay, so the next challenge is actually really on security as well. So being interconnected, it means that security is always a problem for software developers, right? You have to make sure that the product that you're rolling out, they conform to certain framework or certain best practices. So those mean that for system integrators who are going with the DIY solution, what it means is that they have to put in additional effort, right? Additional people who knows all this stuff to kind of make sure that their codes are robust enough to withstand all the different industries and different requirements. So that's another challenge for DIY solutions. So the goal of our TKE, which is the ThingWorx Kepware Edge solution, is to deliver connectivity to legacy, enterprise, analytics, and industrial IoT systems without creating custom code. So instead of you going out to do a DIY kind of solution, you get SDKs, you write your own codes and things like that, you could just reach out to Kepware and get a copy of it, test it out, and if it works well, just roll it out. And then along the way, Bing Kepware will manage it in the same manner as we have managed the KEPServerEx Enterprise, where we will roll out continuous patch and continual bug fixes and those things like that. So you can actually just, let's say there's something happening, and then you see that in our change log that we have fixed that. You can just download it and then just load it up and then just patch it up. So that will really shrink down in terms of maintenance, time for connectivity, and really that's a key value of that. Right, so these are just a summary of some of the key values that that the TKE offers. I don't think I will go too deep into this, but the key thing will be the elimination for the need to code, right? So you don't really code out the full stack, but rather you just configure it, maybe through programmatically through a REST call and things like that. At the same time, the product itself will also offer you the traditional OT connectivity that you require. For example, you want to connect to a PLC and things like that, you can just use the TKE to do it. So out of the box, the product itself, which is the TKE, is a drop-in configurable application, right? So there's not much custom coding or anything. It's just a configuration programmatically. So what the reason why we do it programmatically is that it allows you to kind of quickly deploy it on thin clients, right? Which we'll talk about later on. The next thing that we have is in terms of security reliability, because Kepware will be maintaining the software, we will be providing the best-in-class security and reliability on the product itself, right? So the TKE, in a very broad overview, is what you see over here, right? It's out of the box. You download it, you use it, you configure it, and that's it. It's a headless design, and the code base that is used on our southbound layer. So if you're a Kepware user, you may have heard of the term southbound. So the driver layer is actually the same code base that we use on the Windows version. So the Windows version, being 20 over years, we have patched for continuously, and we have a very proven and reliable connectivity solution. So that same code base is being used on this product as well, right? And if you're a ThingWorx customer today, it has the native integration to ThingWorx, so you can actually connect directly to ThingWorx using the TKE itself. And as of launch right now, we have 3 primary drivers. So Allen Bradley control logics, the Siemens S7, and the Modbus driver. So that's the area we call southbound, where we connect to machines. So if you look at the diagram, right, pretty much these are the complete offering that we have right now. And for the northbound, which is, after you collect the data, you want to send it out. Primarily, we have 2 options for you right now. We have the OPC UA server and the MQTT client driver. So the MQTT will allow you to publish data to MQTT brokers, or even most of the cloud platforms out there. And the OPC UA will allow you to connect to some of the more Industry 4 devices that are OPC UA ready. So as of launch, this is our specification. So again, I won't go too much into this, but what you should know is that our current supported OS is Ubuntu, and we plan to have a couple of other OS along the way. In terms of supported architecture right now is 64-bit and x86. So the next one will be ARM, right? And this is a summary of what we have. The product itself is following a subscription pricing. So the reason why we have went with this method is that because of the security requirement, we recommend customers to really just subscribe, and so that you'll always be on maintenance. And because of the way we designed the product, it was designed to be easy to patch out. So the idea is that with an active subscription, and when there's a new vulnerability discovered, we will roll out a new patch. And because you're on subscription, you don't have to worry about whether you're on support or not support. So you just need to download it and patch it up, right? And that's good for everybody, right, in the industry. So PDC is committed to provide the tools required for securing the critical infrastructure, right? So really, if you're serious about security, it requires you to go into this kind of business model. So in terms of roadmap for the TKE, which is just the Linux version of Kepware, we are at 1.1 today, and the next upcoming one will be 1.2. Yep, and that's the end of my presentation.
Thank you, Steve. Uh, that was quite insightful and informative. And I saw during your session a lot of questions came on trickling
Already.
along.
Wow.
So we have some power packed questions waiting for us now.
Okay.
Okay, so we will have a quick round of Q&As with our panelists for today. I'll be reading out these questions and then we will accordingly see who is going to answer the questions from our panelists who are present with us today. Uh, we have another panelist who has joined us is Manish. Hi Manish, thank you for joining today's session. Right. So Manish heads the ATS India division for us, and many of you may already know Manish for his contribution towards the engagement with Kepware. The first question that we have today is, does Kepware support pure unsolicited data access? I guess Vivek, you will be the best person to answer this for us. Can you unmute yourself and answer this one?
Yes, it is there. So unsolicited data access is possible, but we require the more information about that things, which type of the unsolicited data access is there. But
Okay.
it's possible to access that data from this to the Kepware also.
Okay. Okay, that's good to know. Thank you, Vivek. So the gentleman who is asking the question can reach out to Vivek offline. You have Vivek's details, or if you don't have it, we will share it at the end of this session. So you can reach out to Vivek for more information, share, exchange some details that Vivek needs, and we can take this further. The next question is, can KEPServer pass data from device driver directly to NiFi or Kafka? I guess, Steve, this is straight in your line of defense. So, yes,
Okay.
Steve.
So it's quite straightforward for NiFi or the Hadoop
Yeah.
platform, or is it Cloudera? Cloudera platform.
Kafka is what they explicitly mentioned.
Right. So it's part of the complete Cloudera platform. So you have to move the data from NiFi into Kafka or things like that. And the way to do it, there are two methods primarily. One of them is OPC UA. There's actually an OPC UA. I think there is an OPC UA node or processor in the NiFi that you can use to connect to Kepware through the UA method. And the other method will be through the REST server. So you can actually issue REST calls into Kepware's IoT gateway to pull the data out into the NiFi platform, and then from NiFi, move it to Kafka or even Hadoop.
Yep. Thank you. I hope that was a satisfactory answer. Again, as I said, a note, if you have some follow-up questions to the justifications that our panelists are sharing with you, you can reach out to them offline over an email, and we'll be happy to take these discussions ahead. The next question I have is one of our attendees is trying to ask is, if there are 500 tags which needs updating every 1 millisecond, what kind of hardware would I require at the KEPServer end? There should not be any buffer overflow at the Ethernet port. I guess, Nilesh, you can answer this one for us if you're comfortable.
So typically,
Yeah.
like a millisecond wise communication with any device with Kepware. So you need, first thing you need to verify is like response time of that particular device. So default like minimum time configurable is around 10 milliseconds in Kepware. And hardware specs perspective, you can go with like gigabyte like Ethernet card, and with like 16 GB RAM, and for the requirement. Mainly 1 TB should be enough. If you are not logging the data with some Kepware data logger or to a relational database. So it is possible, but 10 milliseconds is the like minimum scan time we can configure with the Kepware.
Okay, thank you, Nilesh. The next question I have is, does the KEPServer becomes a US server for all the data it extracts from PLCs, on DA servers to a UA client. I guess Manish, if you can unmute yourself and take this one, we'll be happy.
Yes, yes. So all KEPServerEx drivers are called UA as well as DA server. And what is described is a very common application. So customer would have a device communicating over a DA, and KEPServer takes the data over DA, and then it communicates as a UA server to a UA client. So this is a very common application of converting traditional DA devices over UA to a UA client application. So yes, this is very well supported, and that's the standard capability of any KEPServerEx, let it be a single driver or a manufacturing suite or any other suite what you use.
Okay. Well, while we are with you, Manish, we'll like you to take the next one as well. How does Kepware Edge compare to KEPServer in supporting devices? Let's say if the user wants to get data from entire factory floor to cloud with wide range of device manufacturing, is it a good solution?
So I think this is a good question, and I think a lot of customers who are on the IoT or Industry 4.0 journey, I think they would have a similar questions. So what so traditional KEPServer has been running on a Microsoft based system. So you require a typical computer system with a Microsoft OS and the system to connect device to KEPServerEx. So what KEPServer Edge does is that it allows you to use the low footprint Linux hardware. So you can use any low footprint hardware, and typically in a plant you would have a diverse asset. So you can put a small edge device close to your assets, install a KEPServer Edge, and then get data over UA and pass it over the network. And you need maybe just one computer system at the central layer, and all the Kepware data, or even your edge device can directly communicate to your cloud or any other application. So this edge really facilitates you to optimize your hardware network and the infrastructure requirement. It gives you a very optimal way where you can connect your disparate data source aggregated at a very and any very instead of don't require to run long network cables and put everywhere a Microsoft system. Just put a small edge device running on a Linux or Ubuntu, put a KEPServer edge there, get the data, and then connect to your application. So yes, if a person who is asked question, if we can even share the architecture, we can help optimize the right way of using the KEPServer edge in maybe a combination.
Okay. Thank you, Manish. I hope that information was helpful to you. The next question, I guess, Niresh, you can take this up, is KEPServer also MQTT consumer?
Yeah, so KEPServer basically supports IoT Gateway plugin. And in IoT Gateway plugin, you can have MQTT, like you can subscribe as well as publish to MQTT broker. So it is possible basically.
Okay. And staying with you, I'd also like you to take the next one. Is KEPServer a REST server too? Let me repeat it for you. Is KEPServer a REST server too?
Sorry, is it diverted?
REST, R-E-S-T. Is KEPServer a REST server too?
Yes, Kepware has a REST server interface on the IoT gateway, which I'll be doing the demonstration later on.
Okay, so we've got that covered in the later half of this session. So, yes, lady or gentleman, we're going to get your answers during the course of the session. The next question is something that we would like you to take, Steve. The question is, how many drivers does Kepware Edge support?
So the Edge right now currently only supports the Allen Bradley, Modbus, and Siemens Ethernet. However, if let's say you have a certain requirement, please feel free to reach out to Sala so that we can know about what requirement you need, and because we have an intention to eventually add in all the drivers into the Edge version. So if you have a certain project that you are looking at, if let's say it makes sense, we will actually speed up the development and push it in for you.
The next question, Steve, again, I'd like you to take. This is, I guess, a corollary to the earlier question. Can you send commands for third-party REST servers?
Unfortunately, this is not something that we can do right now. So what you're really looking for is a REST client for us to. Well, it's kind of a mixed bag. We do have a REST client. However, the REST client was designed to post message to a REST server. So I think based on what I'm guessing from you is that you may require to trigger something using the REST client. So if it is pretty basic, let's say it's something that is manageable through the REST client in IoT gateway, then I would say yes, we can do it. However, if let's say it's a kind of, you may need to do a certain handshake and things like that, and then we need to then pass out the payload coming in from the third-party REST server, then that might not be something that is ready today. You will probably have to code out some sort of middleware or to handshake between two of the sites. So, but we do have the UDD driver that is coming up that might be able to solve this problem eventually.
Okay. Thank you. The next question, I guess, Steve, you can take this as well. How vulnerable is Kepware towards a Windows OS-based update in present or in future?
Okay, let me think about that question. How vulnerable is Kepware?
Kepware.
Well, I guess at the end of the day, right, Kepware is running on a Windows platform. So, it's as secure as your other applications in terms of, whatever you're installing on it. If there is an OS level bug, to be honest, there's nothing much we can do because we're on the application level side. So yes, we are vulnerable if let's say there is a certain problem with the OS. However, I want to point out is that if usually for OS related no major critical bugs, they are patched out pretty fast. And for Kepware on our end, we do follow the latest news and we patch out pretty fast as well. If you have been following us, there were a couple of big problems with the OS related security vulnerabilities, and Kepware actually, there was a point of time where we offered a free upgrade for anybody even without support maintenance into the latest version. So that's part of our commitment to make sure that even though you are not in support, but we recognize that security is important, and we actually offer everybody a free one-time mass upgrade regardless of whether you have support maintenance. So that's really how we try to manage the incoming security vulnerability.
The next question again, Steve, let's stay with you. The next question that I have from our audience is, just give me 1 second. Okay. Sorry, the questions are really coming thick and fast, so I'm now losing the questions.
Okay. The custom.NET application?
Yes, the custom, can you read it? Yeah, okay, yeah, so can ThingWorx provide tag data to a custom.NET application? Yes, you're right.
Okay, so I assume that you're talking about Kepware, not ThingWorx.
Yes, ThingWorx.
But for Kepware, yes, you can have a custom.NET application connected. So there are a couple of ways, to be honest. The more traditional way would be to access through OPC. And if you really are going through that direction, as I mentioned, client Ace, which is our SDK is kind of reaching the end of life. You can evaluate other SDKs. So once you have the SDK, you will be able to add in OPC capability to your .NET application. And with that, you are able to connect to Kepware. So that's the first method. The second method will be through the IoT gateway. So instead of going through the whole OPC UA SDKs, you can actually issue your own I say REST calls to Kepware to get the data. So I'll be demonstrating that in the IoT section later on.
Okay, thank you, Steve. Vivek, can you take the next set of questions for us, please? The first question I have for you is, how can read internal tag from FANUC machine?
Yes.
How can we read?
Yeah, actually for the FANUC, having his FOCAS library is there. So For that, it is there particular in the memory tags or internal tags is there. Then we can read particular things into this FANUC machines. So
Okay.
library having so many informations are there. We look into that library, then we can read that memory tags or internal tags are there. We can read that particular things.
Okay, I guess we have some information on this coming up in the subsequent session, so maybe we can elaborate it during that
Yes,
point.
certainly.
The next question, Vivek, for you is, can we log datas in the form of table using ODBC driver to SQL database? For example, 3 rows and 3 columns, that is 9 tags usually.
Actually, this based on the question is particular for data logging. So for that, data logger plugin is available. At ODBC, it is for the different application. Driver is different applications are there. So for based on the application, based on the question, we can go for the data logger plugin, and it is possible to log the data into the SQL table. But the example is given that 3 row, 3 columns, whatever the 9 tags are there, it is possible.
Okay. Thank you, Vivek. The next one, again, I'd request you to stay on for this one. Can we restrict Kepware from writing back to the drivers?
Yes, it is possible. You can configure either on the read mode only. You can restrict that to the devices. That is in the tags properties also.
Okay. Okay, the next question again, Vivek, for you would be, each field consumes 1 tag. Is it correct? I don't see this as a question or
yes. So it is basically
but
yeah, it is basically my thought process is it is basically for the data logging purpose. That field is nomenclature of that data logger or some SQL table or like this. So yes, correct. So each field is consumed 1 tag. It is correct.
Okay. Steve, the next one's for you. Can we connect multiple interfaces?
I'm not exactly sure what interface we are talking about.
Okay.
Maybe he's coming in, say, from can we connect to multiple Kepware? Maybe multiple Kepware interfaces? Yes, through OPC UA. Or are we talking about maybe multiple devices? So each of the protocol can be considered as an interface. Yeah, so definitely yes. So Kepware is usually used for interoperability to connect to multiple interface.
Okay. Well, we've answered quite a few questions, and the questions are still trickling in. But in the interest of time, the attendees are to be informed that we will be just taking 2 more questions now, and then we will move on with our subsequent sessions. We'll come back to the remaining questions during the end of the session. The last 2 questions for this round is, Steve, again, you can answer this for us. Can Kepware directly connect with TwinCat PLC in future?
Oh, we can actually connect to TwinCat right now. So
right now, okay.
Yeah, we have the backoff driver, so you can actually use it, but you may need to do some ADS routing. But yeah, we can definitely do it right now.
Okay. And the last one that we're trying to take now is presently in KEPServerEx, we can't stop and restart a particular channel when some distribute happens. Can it be possible to restart a single channel?
Oh, let me think about that. I'm assuming that you have some issues with a single channel, and then you try to delete or make changes, and then you realize that it doesn't work. So that's really one of the design element of Kepware. So it was designed to be such. What you can do is that you can actually disconnect from runtime and make the changes, and then when you reconnect back, Kepware will ask you if you want to update the engine or rather the runtime, and if you choose to do so, there will be a disconnect. So I could warn you that there will be a disconnect, and then it will reconnect back. So that's one way to do it. And the other way to do it is to kind of use your client to cut off data requests to that particular channel, and then you can actually like kind of do things to it. Then if you really want to really just to restart the single channel, what you can do, right, is that you can double click on the device, and there will be a column, no, there will be a row that says data collection. You swap it to disabled and click apply. So that will stop the entire communication on the driver layer. And then you can re-enable it. So that will be, in a way, restarting a single device, not channel. But yeah, you can definitely do it on using that data collection method.
Okay, thank you, Steve. Just to make sure that I also know something about Kepware, I'll try and answer one question for you. So the next question is, will a recording of this webinar be available? Yes, it will be. And I'll take that question for all of you guys. So the webinar recording will be available and we'll share it with all of you. Okay. I see still questions are trickling down. We'll take it during the course of the subsequent sessions. We do have time for enough of your questions. I hope we do, because that's how it was planned. We wanted this session to be as interactive as possible. Now we move on to our next set of presentations. Nilesh, if you can take over the screen, please. So the next session that we have would be from Taranjeet, where Taranjeet will share his experience about how their organization Addverb is using Kepware in various ways and how are they benefiting from the power of Kepware. Taranjeet, over to you.
Yeah. Hello everyone. First of all, I would like to congratulate the entire team for celebrating this Kepware Discovery Day. Going further, first I would like to give a small introduction towards the Addverb. So, Nilesh, can you take to the next slide? So, next please. Yeah. So, Addverb Technology is an automation solution provider company for warehouse. It starts with providing movability of the contents, the software, pallets, cartons, bins and all. Then we help in sorting out the bins, then the picking applications. And also in terms of software, we provide WMS and WCS to manage the inventory and keeping the control of all the drivers and the machines in the warehouse. Next, please. Nilesh, next, please. So presently, the Addverb is a team of 250 engineers, where we have close to 55 and more engineers only into R&D, and we have a good basket of customers as of now, and it's going up day by day. And this year also, we are doing a very good project for some of the well-known companies in India. Next, please. So in our basket, we have mobile robots, then we have automatic storage and retrieval systems, then we have a picking application that's in terms of voice and live. In terms of pick to live, we call it a Rapido, and in terms of pick by voice, we call it a Cushion. In software segment, we have a warehouse management system and warehouse control system. Next one. So in the AMR segment, we have two kinds of AMR. That's AMR on actual navigation. Then we have AGV guided through a barcode system. We have a thinner which can handle from capacity, load capacity from 5 kg to 1500 kg. Next, please. In the shuttle segment, we have a variety of shuttles. The top one, which you can see on the corner, is Quadrant, which is a shuttle which handles the bins. Then we have small cartons and totes. And then the bottom, you can see the red color shuttle, that is the automatic storage and retrieval system. We call it a mother and child shuttle. And on the left side, on the right side top, we have a pallet shuttle, which handles the big pallets, which you can see on the central screen. Let's say next, please. So then we provide all types of conveyors, spirals, roller conveyors, belt conveyors, chain conveyors, and we have a solution in terms of smart conveyors, like if these conveyors can be manage the total delivery of their own also, and they can be guided also, they can be controlled through using various PLC and controllers.
Okay, Taranjeet Prajwal here. Apologies for interrupting,
Yeah,
but
please.
can you come closer to the mic, please? Because
Yeah,
we are not
please.
we're finding it difficult to hear. Yeah,
Sure,
thank you.
sure. Now it's better. Yeah. So on the conveyors, I was saying that we have we supply a variety of conveyors. Like you can see on the screen, the spiral conveyors. Then we have roller conveyors. Then we have belt conveyors, chain conveyors. We use these applications for sorting, delivering, and even for removal and automatic storage and retrieval system. And we have smart conveyors which can manage the load as per the presence, and they can be controlled using various PLCs and controllers. Next slide, please. So when it comes to the Kepware relationship of Addverb, so generally we follow this kind of network architecture where on the top we have a SAP or ERP system which comes from the customer end that talks to our WMS, which is our software. This is a warehouse management system which handles the inventory. And then we have a WCS, which is warehouse control system, which controls the various ASRS solutions, where AMRs and other PLC devices in the peripheral or in the field. Then we have a GUI, which is purely based on the WCS software only. This WCS software integrates us to the various machines through Kepware server. We use Kepware server for talking to the shuttles, as you can see on the left side. And in the bottom, you can see we connect various PLCs. Those we use drivers from Siemens and also that talks to the Kepware server and provides related information to WCS and WMS. Next, can we go to next screen? So here you can see the drivers. Right now we have been using Siemens and Omron drivers. The Omron driver we use for controlling our mother-child shuttle, and Siemens drivers we use for our carton shuttles, the Quadron which I've shown you. And at present, our majority of projects have a conveyor system control on Siemens platform. So Siemens becomes our primary driver which we use on Kepware. In the near future, which is under our R&D project, Mitsubishi and Addverb, that will be using in the very near future. Please, can you move to next slide? So on terms of WCS, the information is connected on the REST line. We take the information from Kepware, which is managed by WCS, which further passes on the actuation information to the WMS, based on which it manages the inventory control in the field, which further helps in controlling the whole management of the contents in the warehouse. That makes the whole warehouse a automatic managed warehouse, or you can say a dark warehouse, where you can say there's hardly any manual intervention in the warehouse, and the whole that primarily supported by the Kepware, which integrates all the machines, robots, AMRs with respect to the WCS and WMS. Next slide. So right, as just in the presentation, you can come to know that we have been using Kepware close to now 2 years and little more. So we have been receiving a various kind of advantages in using Kepware. Obviously, the first one is integrating multiple devices. Like just mentioned, we have PLC platforms controlling you can say conveyors. Then we have a PLC banks which controls the various shuttles, AMRs communication. And going further, it also provides a flexibility where we use multiple port drivers. Like in mother and child configuration, we have a mother platform on Omron PLC, and the child platform is on Siemens. So we integrate these two platforms through this Kepware server. Going further, it's obviously it's easy to install, easy to maintain, easy to configure, and surely it's easy for in case of troubleshooting also. And obviously it supports us in integrating the whole system with our WCS and WS. So it provides a good control towards the IT applications, and that too obviously anytime and from any location. So I'd like to say that Kepware has contributed a lot in our success. Thank you, Nilesh.
Thank you, Taranjeet. That was quite insightful for us. Taranjeet just demonstrated what a solution provider can do with the power of Kepware by leveraging the various technologies Kepware has to offer. So that was quite helpful, Taranjeet. Thank you. Should you have any questions for Taranjeet, just pop them in the Q&A box and we will try to answer that. Taranjeet has been kind enough to agree to stay till the end of this session so he can get the questions answered for you. Moving on to the section of major drivers, now Nilesh will take us through the various drivers that Kepware has and how we can use it. And we also have some demonstrations from Nilesh. Nilesh, over to you.
Yeah. So good afternoon, everybody. I'm Nilesh Jangle and I'm working with pre-sales team in Sarla Advantek. So for today's topic of Kepware drivers, we will be basically majorly will be going through the Kepware configuration tool itself, and start with we'll go through few slides which explains basically basics of Kepware driver. So if you see this particular architecture at bottom side, there are various data sources which are connected to Kepware EX. And at the top side, there are certain applications which are exchanging the data from. So basically this application or clients which are connected to Kepware request data from KEPServerEx on like explicit read write, hold or subscription method. And once data is available with KEPServerEx through like some necessary client interface, it is served to these clients. Like necessary client interfaces may be like REST or any native client driver or ODBC. And apart from this, Kepware also supports certain plugins advanced plugins, which adds more functionality to this collected data. So our main focus in this topic will be on drivers. So we'll be mainly focusing on drivers. So if you see here, drivers are how Kepware EX connects to your data. So various data sources, like it may be like PLC, it may be like OPC server, flow computers or database applications. So Kepware EX communicates with these data sources and devices using wide array of drivers. There are a lot, 150 plus drivers available with the Kepware. And this drivers supports different kind of like physical interfaces. It may be like Ethernet or serial and protocols such as Modbus, BACnet or CIP. So if you see, this is the list of drivers which is supported by the Kepware. As I said, there are almost 150 plus drivers available with the Kepware. And for this demo, we'll be going through some of the like major drivers. So if you see here in this slide, I have mentioned or listed down certain major drivers. So we'll go through the configuration of these major drivers, named Allen Bradley ControlLogix Ethernet. So for this, we have ControlLogix PLC, ControlLogix L72 PLC connected to my laptop. Then we'll go through the OPC UA client. For this, we have iFix running on the system, which will act as an OPC UA server. And we will use Kepware as an OPC UA client. And third, we'll go through Modbus Ethernet. So for Modbus Ethernet, we have one system on a network where I install Kepware instance, which will act as a Modbus slave. And the instance which is installed on this laptop will act as a Modbus master. So typically most of the cases system where a driver will be installed will act as a Modbus master, and the field devices with Modbus protocol will act as a slave device. So and finally we'll go through the configuration of Siemens TCP Ethernet. So from like driver configuration perspective, there are three major connectivity terms associated with that. For channel. So channel is nothing but like your path to the device. So when you configure channel in Kepware, you need to specify the path or driver which you will be communicating with. So that you need to select in channel. And apart from that, you need to specify the port which will be coming to your device. So mostly it will be like Ethernet card on your system. In some cases, if it is like serial communication, it may be like serial port. And next will be like device. So in device, you will be mainly configuring like a model. You need to select particular model. Then the that will be like IP address of that particular PLC. And as informed by Steve in earlier session, this data collection option will be there, like to enable or disable that particular device under the channel, so that that particular device Kepware will not point to that particular PLC or device. And finally, we need to create basically tags. Tags can be created using this tag property editor. And in this property editor, you can see we need to specify the tag name as per the requirement, and the address. This address syntax might be different for each protocol and each PLCs as per the specific syntax provided a specific PLC vendor. So you need to specify that address with the data type and client access for like read write access to be provided to client for that particular tag. So now we'll move towards actual configuration tool, Kepware configuration tool. So I'll just switch over to Kepware configuration tool. So this is the Kepware. So this is the Kepware configuration tool. Currently I have configured one project with listed drivers. So if you see like in project connectivity, we can create new channel, and in channel, first thing which we have to do is we have to select the driver. So first demo, I have this Allen Bradley channel already created, which is communicating with network L72 controller. So we'll just go through some of the main settings available under channel. So if I go to property editor of the channel, you can see I have selected driver called as Allen Bradley ControlLogix Ethernet. So as ControlLogix PLC, we have to select this particular driver. In case of it is like SLC or older PLC, we can select Allen Bradley Ethernet protocol. Or if it is like DH plus combination or DF1 combination, we have to select respective driver. And then again, there is one option called as a diagnostic capture. So this diagnostic capture is nothing but when you face certain like communication related issues or certain like you need certain optimization in your communication, you can just enable this diagnostic capture to see certain statistic related data for that particular channel. Basically this diagnostic capture basically takes minimal overhead processes. So it is that you enable this only when it is required. And as described earlier, like this 6.9 provides this tag count also. So you get this static tag count available with that particular channel. And then another major setting is like you need to configure basically adapter. So adapter which is communicating your PLC. So in this case, I have that PLC on wireless network. So I selected a wireless adapter of my particular laptop. Other things will be in device, like major things will be in device properties. So after creating channel, we need to create device. So in device, I have selected basically the model number. So these are all models supported by the Allen Bradley ControlLogix Ethernet. So these are all series like ControlLogix 5500. So you can have like L72 processor will come under this particular model itself. Then I have basically enter here IP address of that PLC, which is 10.91.16.2. And if you see here, there is one constant number that is port ID, and then there is a CPU slot. So we need to specify the slot. So this ID will depend on each PLC driver or each PLC vendor. So you can just go to help and check the syntax for the ID. So for Rockwell, it is like IP address, comma CPU slot. And then you can obviously have this data collection enable or disable for that particular device. Then some of the major setting available with like device is like scan mode. So by default, it will respect your client specified scan rate. So whatever client will have or whatever scan rate is configured in the client, that will be applicable for the all tags available in this device. So you can also have like tag based tag specified scan rate, which is available in the tag property. You can also specify one particular scan rate for all the data, or you can also specify only. So this demand pool is mainly used in like a remote station where bandwidth or some communication delays are there. So you can basically client will write to one tag available in Kepware properties as a demand tag. Then only Kepware will send the information. So where data is required only on demand basis, then you can use this demand port to avoid network uses or bandwidth of your particular communication. So currently we have selected client specific candidate, and there are certain settings like timing which are typically available with drivers like communication timeouts, like the connection timeout to establish the connection, then request timeout if like there is no response from the particular device, and for declaring that device is failed. So when you get basically at the bottom side in event logs, if you get basically certain messages like your device is not responding, so that happens after this particular timeouts occurs. So and apart from that, some of the major with device are like tag generation. So with certain PLCs like Allen Bradley, Siemens, even Modbus, OPC, so they support basically automatically tag generation. So for that, you can specify certain settings like whether you want to generate this automatic tag at startup, you want to delete duplicate tags, and you need to specify here database setting. So these database settings are nothing but like whether you want to import this tag from device or you can import this from import file. So Rockwell supports basically like exporting your program to this L5K extension. You can also use that, or you can directly create tags from the device itself if that device is connected to your system. So these are the main setting, and apart from that, another thing is like redundancy. So if there is like, so this is basically a media level redundancy plugin, which is now part of the Kepware driver itself. And so when you purchase the Kepware drivers, this media level redundancy feature will be available with that particular driver. So if you have like a redundant controller, and you want to configure that, you can just configure two devices and just put that second device in this secondary path. So whenever there is like a failure with primary device, the secondary device will take care, and the client interface which is connected to Kepware will be basically connected to your primary address only. They don't like, you don't have to change the addresses in like your client device or client application. So this is very useful redundancy. And next part is like tag generation. So as I said, I only like automatically created this tags from the tag generation option. So just create the tags. For creating the tag, in connected to runtime of the Kepware, and you can just click on create tags. It will automatically generate the tags. So for this demo purpose, I have created certain like tags in the PLC. Rockwell PLC uses alias addressing, which is like you can have particular alias for the tags. So we have just given a name as some of them are real, boolean, integer. So to verify the data, I can go to quick client. So I'll go to quick client, and in quick client, you can see that for my L72 controller, this data is currently live coming from the PLC. Some of them are real tags, some of them are like boolean tags, some of them are writable tags, string tags. So this is how you can communicate with like Allen Bradley controllers PLC. This automatic tag generation feature makes this configuration like very easy. And if you go to like, if you want to make tags manually, then you can also create tags manually by entering information here, as well as you can also export this data to CSV, do the like appending and other tags in the CSV and configuration in CSV, and import it back to reduce your like development time. So this is how Allen Bradley configuration is available. Next, we'll go through Siemens. As Allen Bradley and Siemens, more or less configuration perspective, it is almost similar. So if you see like properties, channel properties of Siemens, I have selected basically Siemens TCP IP Ethernet. So this will be typically used in a like S7300, 400 or 1200, 1500, which has basically Ethernet port available in there, or you have some communication card like CP 343 or 443 or CP2434 S7200. So you can use this particular Ethernet card, and you need to select, again, you need driver, and you need to select the port which will be communicating to your PLC. So in this case, I don't have any PLC, so we'll just go through the configuration for S7400. So if you see here in device properties, so there is basically IP address which we need to put as ID for Siemens devices. Most of the other settings are common, like data collection, static tags, scan mode, timings. Only major difference here is like communication parameter, which is like port number. So typically, like Siemens uses 102 port for communication with like Siemens TCP. And if you are using like MPI to Ethernet converter or Profinet converter, in that case, like Netlink is like MPI to Ethernet converter. So in that case, you need to specify here MPI ID for that particular Netlink converter. And apart from that, again, with Siemens also, automatic tag generation is possible. So you need to specify here like if you are using TI portal, you need to use basically one TI portal exporter utility, which is available with the Kepware setup. You can just export, select your project file of TI export, and you can export it to this particular extension TP and just browse it, and you will be able to generate the tag Kepware configuration. And if you are using step 7, in that case, obviously you need to specify here S7P, like your project file and your program path. So this is how you can just configure the device properties. Redundancy will be again like common. Then like to just give you like how addresses are configured with Siemens, we can go through this particular like tag list where I have configured certain words. So typically in Siemens, we have DBs. Typically data is moved to data blocks, and for word, there is this kind of syntax is there. For digital tags, syntax is like db3.dbx. So if you want to know what syntax we need to put for data type, you can always browse this particular address tab. You will get the hints, or you can go to help to understand what exact addressing type will be required. So this is how Siemens configuration is available. So typically these are some like commonly used addresses with Siemens PLC. Next we'll move towards Modbus. So for Modbus, I have one system on network. So I'll just switch over to that system. So this is that system on network where Kepware is running, and Kepware is acting as a Modbus slave. So TCP driver of Kepware supports master as well as slave. Both modes are supported. So when you put your channel IP address, this particular card address, and your device IP address, same IP address, if you put here, it will act as a, or you can also put like host ID that is 127.0.0.1. So this will act as a slave in that case. So I configured certain tags, and you can see that I have added certain values to those tags. So these are like currently like acting as a Modbus device or Modbus PLC for me, like Modbus slave device. Now I'll go to my system where Kepware is running. So in this, in properties, obviously I have to select again driver, then my card, which is communicating to that particular network system, which is again on my wireless system. And then I can go to the device properties. So if you are in device properties, you can find out that I have put the IP address of that particular system itself, which is running that Kepware instance as a slave. And here in Kepware like Modbus device properties, you have certain options. Like again, it also supports this tag generation, but this tag generation is supported only by certain programming softwares like Concept, Snyder Concept, and ProVox. So if you have those programming software, you can basically have this input file, and then you can generate automatically. But anyway, basically tag addressing in case of Modbus is in basically there is a typical syntax. So you can always export it to CSV and do the changes. So apart from that, some of the major settings available with Modbus device properties are like this data access. These are related to Modbus protocol, like if certain devices, if they support zero-base addressing or zero-base bit addressing, you can enable. So in Modbus, this is basically there are function codes like 6 and 16 for single register write, 5 and 15 for single coil writes. So if those are there, you can basically enable these two things if your device supports that. And obviously from data encoding perspective, you can have like certain modicon bit order or Modbus. So this will have your, if you are like communicating with particular device and your data value or value of that particular tag is not proper, you can just try out this particular encoding settings. But by default, most of the devices should work with these settings. And apart from that, again, yeah, so that's all from Modbus side. So if you see here, after creating device, you can create basically tags. So typically in Modbus, there are 4 types of addresses. One is like input status, which starts from basically 1, which is like digital input. Then coil status starts from 0. Then starts from 4, and input register starts from 3. So you can have basically this kind of addresses. And if I go to quick client, you can see here, if I go to my particular Modbus device, it is just replicating whatever tags values are available in my Modbus slave device. So I can even, if it is like status, I can even write the value to particular device from Kepware quick client itself. So if I made this digital output to 1, and if I go to my slave device, my particular tag is also 1. So this is how Modbus communication or configuration will be available with Kepware. And as these addresses are in particular syntax, you can always export it to CSV and do the changes and import it back. So this is how Modbus is there. Then we'll move towards like next configuration, that is OPC UA. So again, in OPC UA also, you need to configure basically. So first of all, I'm using this iFix SCADA as OPC UA server. So in this is the interface for iFix SCADA where we need to basically enable the OPC UA configuration. So I have enabled this OPC UA server at iFix level and other like properties related to OPC configuration. So if I go here in Kepware, I need to basically, while creating the channel, instead of now, obviously you need to select the driver, but instead of selecting like network adapter, you need to specify here endpoint. So endpoint is nothing but like URL. So basically OPC UA server and client communication happens through this URL. So you need to specify here URL, so which is available from your OPC UA server. Then you can specify here security policies and message mode. So these are related to like if you want secured communication, you can select basically this basic 256 SHA 256 and with message mode as sign and encrypt, so that you trust your client communication as well as exchange the certificate between UA server and UA client. So this will happen automatically from OPC UA server interface as well as UA client interface. So you can enable this, and obviously if at UA server end, if your like anonymous login is then you need to specify here username and password of your OPC UA server settings or configuration. So I put here UA server username password, as well as at my server end, I also basically trusted the client, this client. When I try to connect for first time, it will pop up this kind of window, and you have to trust this particular client. Similarly, the case with OPC UA server at the like Kepware configuration also. So you need to basically specify that, and then you need to go to device. There are very less setting because most of the settings are available in channel. In device, you need to specify basically the subscription, like how your like client driver will publish your like data, as well as how the subscription will happen. So subscription can be either exception based or poll based. Is like whenever there is a data change, it will be like publish, and poll will have like on poll basis, particular interval basis. And there are other settings like interval. So sampling interval is how Kepware will basically interact, or Kepware will poll to that UA server. So this should be always like half of your publishing interval. So publishing interval is 1 second, and my sampling interval is like half of like 500 millisecond. So every 500 millisecond, I'm getting the data at Kepware level, and from Kepware level, I'm publishing it at 1 second. So again, it is very easy with UA. You can directly browse the tags. You can select particular tags. So this hierarchy will depend on your UA server. Like for analog input, digital input, these are all tags available from iFix. So I selected these tags and I configured a few tags already. So you can see here addressing is like this is a namespace too. So this address will be automatically generated. So this is like namespace, and the data type, like this addressing syntax or data type, that is string, and with your respective tag name. And if I go to my quick client and just verify the tags, you can see that values are coming from iFix. And if I go to my iFix screen, so these are all the values which are available with the iFix. And these are all values, same values we are getting from iFix, like this batch ID, then certain like inlet temperature or certain values. So all this data is coming from iFix. So this is how basically OPC UA configuration can be done in Kepware. So I think we have covered like majority of driver. Obviously, there are a lot of like around 150 plus drivers available with Kepware. Always go to the driver help and see the exact configuration. But conceptually, the configuration will be similar, like channel, device, and tags. So only thing like addressing syntax or maybe your device ID syntax will be different. So this is how you can configure the drivers in the Kepware. I think that's all from my side. I think we can move towards our next topic. So over to you, Steve.
Hello. Let me just share my screen right now.
Yeah.
Right. Let me just move this away. Okay. All right. So let me just turn on my video as well. Oops. Okay. Hello, everyone. So welcome back. So I guess this will be my section, which we will talk a little bit on the IoT gateway, right? So the key products of the IoT gateway, as well as the data logger. I see that there's a lot of questions coming in for the data logger. So I tried to answer some of them along the way, but feel free to stay to the last part and really ask us the questions. So for the IoT gateway, in order for us to go into that, I'm going to just give you a brief background of IoT. So it is a term first coined in 2011 by German government to describe a manufacturing digitization project. So the key thing is for IoT is to really just the convergence of the physical and digital systems in industrial manufacturing. So with the convergence of the technologies, what it does is that it allows the emergence of new service and business models provided by smart manufacturing. If you're interested, feel free to follow the link from PDC to read more about what is Industry 4.0. Now, what does that mean to Kepware? Really, the key thing about the whole IoT wave that hit us in the OT side really is about data, right? The data is actually being produced by all these things, which are typically your industrial asset. So it could be a talk to PLCs, it could be an IPC, it could be a UPS, and things like that. So all these things generate data, right? So traditionally, we use the data to present some sort of HMI for the operators to monitor the machines and the data is all displayed on the panel itself, right? So, if you have been to a machine, you could see those like LEDs with the traffic light LEDs. I don't know if you've seen it, green, yellow, red, things like that. So those are all data, all generating data. And really the whole idea is that to use that same data to provide new capabilities by leveraging cloud services or emerging technologies like AI or machine learning, but all those stuff. And really it's all about moving the data from the Kepware's perspective. So traditionally, right, the factory floor, we follow the ISA 95 or some sort of tiered or layered data movement. So typically the PLCs generate the data. You program your PLC, so the logics, the PLD loops, set points, things like that. And then and some of the data will then flow to the HMI, right? So it's post-processed, it's not all the data. Additionally, after that, the data is then being passed on to, say, an MES system, right? And then it can go into the ERP and finally, to a big dashboard where your boss is looking at that, only a few KPI. So typically that's really what the OT, what our experience is from the OT side of things. With the whole IoT wave, we have now cloud services that requires the raw data to be published to them directly. So with that in mind, this is actually an architecture that we are seeing quite common across the board. So you typically separate the architecture into two layers, the edge layer and the cloud layer. So the cloud layer, it could be a computer systems that is, in a central HQ, or it could be even on-prem, right, internal cloud. But pretty much what it means is that when you see the services, there are a bunch of services that you use, right? That can be hosted or it could be on-prem. Then for the edge side, so typically those are like on our shop floor area where we have the machines and things like that, and they're connected through HMI. So in order to kind of deliver the IoT applications or really just to pass data to these technologies, what we are really talking about is the use of IT-centric protocols to pass that data over, right? So if you think about it, most of the data are already out there, right? It could be connected through a software like Kepware, or it could be other software. So the data is there, and as long as that middleware or that software has IT capabilities, right? IT-centric capabilities, you can actually send the same data that is being drawn on the dashboards to these cloud systems directly as well. So that really is kind of the premise of where the IoT gateway is coming from. Right, so out of the box, the IoT gateway today comes with the REST calls, so REST. So we have a REST client and a REST server. So if you recall, someone just talked about like how do we send commands or through the REST call. So that we'll be talking about a REST client, with a certain kind of method that we talk about. However, our REST client really was designed to push data out to a REST server, and the REST server will kind of take it and do something else. So I'll demonstrate later. The next thing that we have is MQTT. So I think there was a question about Kepware as an MQTT consumer. So yes, we do have the MQTT client agent. The MQTT client agent in IoT Gateway was designed to publish data. So it's meant to send out data as well as write. If you want to consume data, we actually have a MQTT client driver to take in the data from an MQTT broker, right? Then last but not least, common to both these agents, the payload format, the format that we use and recognize is JSON, right? And that will be how the IoT gateway is. So for those who are not familiar with JSON, JSON refers to JavaScript object notation. So if you're a programmer, I think this is pretty straightforward. It's a key value pair operation with a bunch of curly bracket. But for those who are not familiar, pretty much the JSON will look like this in this picture over here. So it looks like this, curly bracket with key value pairs. And what we have here in Kepware is that we give you the ability to kind of modify and define a certain template to kind of move the way to form the payload that you will be sending out or receiving. And in terms of RESTful interface, what it really means is the representational state transfer. It's a client-server based architecture. So the client pushes out a request and the response comes back to you from the server. And it's very common to leverage the HTTP protocol, right? Or the SSL version, HTTPS. And the REST call itself is stateless. It's not like your TCP connection where it's connection oriented, you know, where we form a socket, a three-way shake, and then we know whether the connection is breaking or is it still active. For HTTP, once you send it out, you know, you just let it go, and then you will come back with hopefully the server responds back to you, right? So that would be the HTTP, right? HTTP protocol. And for the MQTT portion, basically it's the message queue telemetry transport. It is a lightweight protocol that can be used to transfer data in a pub/sub broker manner, right? So typically, right, you will have your data or sensors having the data, creating the data. And what they will do is that they will send out to a broker, which you have to deploy. So it's not in Kepware, it has to be you have to deploy your own broker. And that broker will then receive the data and put it as some sort of topic. And whoever is subscribed to that same topic will receive the data. So you can see that the data point will then go from here, it goes here, and then it spreads out to anyone who is subscribed to that same topic as well. Then on top of that, for the MQTT protocol, there's a concept of QoS inside. So it affects the reliability of the message delivery. And at the bottom of it, the transport layer is actually TCP/IP. So going back to the diagram that we talked about, today at the edge side, you could be connected with Kepware. And with the IoT gateway, what it does is that it allows you to send the data out to the cloud, or it could be sending out to a local on-prem edge agent, which is doing further processing of the raw data, and then it's sending it back to the cloud. So post-processed data, or it could be just, you know, wholesale dumping of data to the cloud directly. So if you're interested, the IoT gateway, we have a couple of resources for you. The IoT gateway demo video is over there, and then we have a Make Easy guide. So the Make Easy guide is a great guide to get you started because it allows you to create a REST server, you know, in a couple of clicks. And if you are interested, we have the manual and the webinar series as well. All right, so the next one will be data logger. But before I go into that, I think I will do the demonstration for the IoT gateway. Okay, so if you look, I assume that you guys can see my screen. If you are not seeing the screen, no, let me know. Just type in the chat box. What I have here is a system that is connected, a Kepware that is connected to a bunch of PLCs. So you can see that we have a Mitsubishi IQR series over here. We have Automation Direct DL05, and I have a Raspberry Pi sensor, right? So I think, you know, to build on what Nilesh has talked about, once you know how to use Kepware, pretty much the creation and configuration of tags are pretty similar, right? So if you launch the quick client, you can actually see that we are reading data from this machine. Right, you gotta bear with me because my VM is a little bit slow. So you can see that I have the sensor data over here, the Mitsubishi data over here, and the DL05. And as of 6.9, remember I talked about the underscore system. If you look at the underscore system tags, there is now an active tag count. Right, and just maximize it. So there's like 7 tags being read right now. And if you go over to the device layer, you should be able to see the static tags created. So for those who are not familiar, each of the tags created over here are the static tags, right? Right, so this is a very typical connectivity layer where we connect from the OT environment, right? So maybe now you have to do IoT, right? So the first one that would be, I will demonstrate would be the REST server, right? So in order to do a REST server, it's very straightforward. Just need to right click, new agent, and choose the REST server, right? And then you can call it whatever you want, REST, for example. Right, and then you can bind it to a certain NIC card, and pretty much you leave the configuration as shown. So when you do that, right, what it actually allows you to do is to kind of perform REST calls to it. So let me just enable this one. So you can see that it uses the JRE runtime. And once you bind it correctly, right, you will be able to click on the URL provider, and that will bring up the documentation for the IoT gateway. And with the IoT gateway, what it does is that it allows you to do programmatic calls to it. Oops. Let's give it some time. And with that, right, what you can do is that after the REST server is being created, you can actually use, program JavaScripts and stuff like that to actually create your own codes to issue REST calls to the REST server. So that's pretty much what we have done here, right? If you want to, I believe this can be sent out through Scala later on. So we just need to read at the source code, and we have a bunch of scripts for you to test out. And once you do that, right, all you have to do is really to just hit the IP address of the REST server, which is this. And you can see that we are not connected, and there's 0 text right now, right? That's because there's nothing over here. So what we are going to do now is to kind of just create and add in the text that we have. So what I'm going to do is I'm going to just right click and new IoT items, and we can choose whatever we want. So let's just put the sensors data inside, and you can choose whether you want to do a scan rate or an explicit read. So I'm going to just do a scan rate. So what a scan rate does is that the REST server will then scan the text created at the designated rate. So every 1 second, you will look for data. So now if I try to connect again, you can see that now it's being updated with 15 text, which is pretty much all of these guys. And if you just click the display text, you can actually read the text. And you can see all the values over here. Right? And this text, right, again, just to make sure everybody's on the same page, is the very same tag that we have and use it for typical OT application. So it's exactly the same. So that's the first use of the IoT gateway. You know, you can use as a developer, you could be issuing REST calls, and then once you have the REST call in place, you can then develop your own UI or any programs to kind of read with it. So the next thing that I want to demonstrate would be a use of the IoT gateway into Telegram. Like for those who are familiar with Telegram, you know, it's like it's a WhatsApp kind of thing. And then there's a very well documented API for you to try out. So what I'm going to do now is that you can see that I pretty much used a REST client, and then I post it to the API, right? And then I remember the JSON payload, so we can actually define it in a certain syntax. So what I'm going to do now is I'm going to just add in I'm going to enable the REST client that sends it to the Telegram API, and from there, it will actually, see that? It will actually give you certain information. So I have 2 tags right now, and what I'm doing is that I'm making use of the system tag _ system error tag to determine if the device itself is in a erroneous state, right? I can also then send in data if I want to. So you can see that I can enable data, and then I could add in some text, maybe all the text. And then what it does is that you will then take all the data and send it out again through Telegram. See that? So it's the exact same text. So in just a few clicks, you see that we can leverage the IoT gateway, maybe to develop a custom web page to show values. You can also use it to do some sort of simple notification, right? To kind of push out data into Telegram, for example. And the next thing that we can do, right, is to use the IoT gateway to send it to, say, InfluxDB. So for those who are doing things with Influx, right, you have to use the REST call to kind of push it in. So if you look at my screen on the left, right, we can enable the REST client. And then what we can do is that we then add in the text. So again, it's the exact same text. Let me just stop the Telegram because he's spamming me. Right, so you can see that I add the influx stuff in, and if I now do a select statement, you can see the data is all flowing into the InfluxDB right now. Right, it looks a bit ugly because my screen is not wide enough, but yeah. So that's to InfluxDB. And the last one that I can show you would be, say you are sending to another software like Splunk, for example. So you can actually use the IoT gateway to do it as well. So I've already added the text, but it's going to be the same steps. And pretty much if you do a search on it, for those who are using Splunk today, there we go. So you can see all the data into another big data platform, right? So really the use of IoT gateway is pretty flexible. What it really does is that it speaks in the same language as most of the IT software out there in the market. So it allows you to do lots of interesting stuff. I guess I can do one more, which is the MQTT agent. So the MQTT one will be quite straightforward as well. So I have a MQTT broker connected on my PC right now. So I'm going to publish the data into the IoT gateway. So, pretty straightforward. Again, a few clicks, and then I'm going to just add in the text that I want to expose out through MQTT. There we go. And with that, if I use another MQTT client, I can actually subscribe to the same topic and see the data. Give it some time because it's a bit slow. Let me just disable this because my phone is ringing. And it's still loading, so let me give you some time. But pretty much these are some of the things that we can do with the IoT gateway. And for those who are sending to the cloud, we have the connectivity guides from IoT to Azure, as well as from the IoT to Amazon if you want to. So through the IoT hub and then send it out to the Amazon platform. So on top of that, there's also a Greengrass AI IoT Greengrass, which is kind of like a edge side of thing. So you can actually do that as well. So it's all completely documented in the on the web. And I think it's on the right window panel. Yes. So it's actually out. So this will be the last thing that I will show. So pretty much I will connect to the broker, right? A local broker. So it's connecting. And if I subscribe to the same topic, or rather I'll just subscribe to all the topics, you should be able to see the the MQTT messages that is being published. And there we go, to the topic IoT gateway. And these are all the tag and data. Yeah, so that's pretty much the IoT gateway at this point of time. Right. So later, if you've got questions, I guess I will continue to. I will talk. I can take them later on. So for now, I will just move on to a little bit. Just bear with me. It's a data logger. So for the data logger, is really used for data logging, right? So with the IoT gateway, you are able to send data to different cloud platform and things like that. With the data logger, you can use the same data and throw it to a DB, right? So the data logger allows you to put data into any ODBC compliant database, right? Some of the features include automatic tag table creation, as well as the ability to append data to an existing table. So what it means is that if you have a table that you have created and you want to use Kepware to map data into it, you can actually do that in that. The next thing that we have, right, would be the store and forward capabilities. So the store and forward capabilities allows you to kind of act as a local buffer if the connection between Kepware and the database is down. So that's the store and forward feature. So I think there were some questions on whether there is a limit on number of tags that we can lock. So the response from me is that we don't have a hard-coded limit. However, you need to be aware of what is the limitation of the insert command used to throw the data into the respective database. So in terms of logging, right, when we log it, we need to have a way to define when to log it. So those are considered as triggers. So we can either do a static logging, which means that we will give it a certain interval time. For example, on the screen is 500 milliseconds. We will log the data every 500 milliseconds. Or we are looking at time-based. Perhaps you are logging based on shift work. Maybe every day between 8 o'clock to 5 p.m. you want the data, and after that you don't need the data. So that will be time-based logging. And last but not least, we have condition-based kind of logging. So you can actually use a couple of tags, right, to trigger the logging. So if you put into context, you can actually do like a HMI or things like that. You can actually write some sort of logic to trigger the logging. For example, you may want to know whether when the machine is having a certain fault status, there's a certain parameter you want to log. You can actually use the condition-based trigger to actually do that. Right, so going back to the architecture just now, so we can see that we actually just now use the IoT gateway to connect to a bunch of web page. We can send it to maybe a big data platform or even unstructured DB like Influx and things like that. And what we really do is that you can actually also add in the data logger for on-prem logging. Because certain applications that we have encountered or certain architecture, right, they require you to, some of the customers are concerned, say, between the connection of the cloud and CAP server goes down, and how are they going to recover the data? So while the store and forward actually performs that, but some of the customers prefer to have on-prem backup. So that's where customers will actually use the data logger to do that as well. And if you look at this screen right now, this will be how it looks like in the Postgres SQL, right? Postgres SQL. So you are using pgadmin to look at it. And these are some of the useful links that you can take a look at. So we have the data logger made easy, which allows you to quickly kind of configure the data logger. If you're keen, we also have a great video done by my colleague who runs you through the entire process and in a video form. So you can follow them and go along the guides to kind of do it. So as part of my last demo, I'm going to start doing the data logging. So, I have all these things connected, fine. Now I want to do a data logging. So in order to do that, right, if you look at the data logger, all you have to do is just do a right click, new group. And over here, under the DSN, right, click on this 3 button, and typically you will need to configure your ODBC driver under the system DSN, right? So if you click add, then you can choose like whichever ODBC driver you are using for your database. So in this particular instance, I'm using the SQL server, right? A SQL server, and pretty much that's it. So once you do that, you choose the correct DSN that you have defined, right? Just click OK on it. Whoa. I'm sorry, my VMware is very slow today. Right, just click it. And then what you can do is that you type in your database username and password. So I have one that's this. Right, so once you do that, just click OK. Oops. Table data. Okay, the table, right? You need to either create a table, remember, or you can let Kepware create a table and do it for you. So I'm going to just call this table ATS. Oh no, let's just call it Sala. Click OK. So you can see that once the log group is created, you can then start to add the items. So I'm going to just add some items. So let's just use the same sensor data in. Boop. And that's it. So the last thing that you probably want to do is just to enable it. And when you've done the enabling, what will happen is that you will see that the create table command is created and the log group is connected and starting to log. So the next thing that all you have to do now is really just to go into database and just validate that the data is really inside. So I'm using the SQL Management Studio to kind of look at it. So you can see there's a table now called Sala. And if I select the top 1000 rows, right, you can see all the data going in right now. Right, so that's really all we have for data logger, the straightforward product that you can leverage to throw data into database. Yeah. I think Vivek will be running you through the advanced tags.
Okay. Thank you, Steve. That was very insightful. Now we move on to the advanced tags section where Vivek will take us through the proceedings. Vivek, are you there?
Yes, yes.
Thank you, Vivek.
Yeah, thanks, Pajwala. So, good afternoons, and the main topics for this Kepware for one of the plugins, that is for the advanced tag, and another topic, it is for the this is the same for the plugin for the SNMP plugin is there. So advanced tag is basically the thing is one of the plugins. It can be some mathematical calculation. Some of the tags are there. So Dilesh, can you move on to the next slide? Actually, the advanced tag is very useful to have some of the calculations, some of the linking, or some of the logical and mathematical functions. If there is some that is not possible in the SCADA or something like this, you can able to do that all this possibility and with the help of this advanced tag. So advanced tag So can you move the next slide, please, Nilesh? So the first link tag, so it is a very useful and very popular use case of this links tag. So this link tag is basically the transfer the data between the two existing tag in the server. For example, suppose the output of some of the Allen Bradley PLC stack can be used as the input of the Modbus registers. So data can be linked with the trigger. We can use some triggers or whenever the data value is changed or some set for the interval. So as you says like that, some PLCs having some different protocols and the PLC has to link that tag, to map that tag, and we can transfer this tag either from read or write mode, whatever you can based on this application. It can be configured to occurs the always on or the certain condition. You can have some scheduled trigger is also there, or some event you can use that particular for the event, and then to map that tag particular thing. For example, if you use some PLC beat for that particular to trigger that particular tags. Link tag can be also used in many different applications. Suppose, for example, like as the trigger the cooling process. If you want to trigger the cooling process, if the device temperature goes high, goes too high and link this data to the chiller system. Suppose if temperature goes high and you start the chilling systems, that time you can use this link tag to transfer this tag to the chilling system and on that particular thing. Or you can, second use case is also that for the link the recipe data from the SQL database to this PLC when the recipes changes. So many use cases required with the help of this tag. So the link tag is basically mapping that particular two devices tags. So this is the fundamentally it is called the link tag to have protocol linking or something like device linking type there. So can you move to next slide, Nilesh? So in the general terms, why the linking is required? The particular as in general terms, so any OPC server and another OPC server, you cannot able to communicate both servers because it is the client server architectures. So with the help of this link tag, we can use this particular application in the same way. Some device have a different protocols and some device have a different protocols is there. So for that, you cannot directly communicate with this PLC. So with the help of this advanced tag plugin or the link tag or something like as for the linking, you transfer this one device PLCs or one device is having some protocols to transfer that to the different devices. So this is basically why we use the linking. Now, normally for this, the same have discussed with the system, like for the mapping of these tags or mapping of this. So the types of the OPC solutions for that particular things are the total 3 type of the solution is there. One is the OPC server aggregator, second is the OPC server bridge, and the third one is the OPC server bridging is there. So particularly in all these 3 solutions, ultimate goal is to have the data can transfer to the OPC server, multiple OPC server into the central locations or something like as a, because the server to server communications are not possible because it is the client server architecture, and then we can use these 3 solutions to compensate that particular application. Can you move to next slides, Nilesh? Actually, the 2 solutions for the OPC server bridge, so can be possible with the help of the 2 solutions. One is the link master. So link master is the NAC, it is the KEPServer product is there. So in detailed discussion with the next session about the link master. In the similar manner, with the help of the advanced tech solution, we can use the OPC server, what is the UA and DA servers and advanced tech plugin. You map that particular OPC bridge is there, OPC bridge is there, you can server to server bridge is there, and with the help of these bridges, we can collect the data from the 2 OPC server, and either we use advanced tag to link that tag, or you can have some mathematical calculation if required. So next slide, please, Nilesh. Yes, here the thing is like that, OPC server aggregators is there. So in the similar manner, there's 2 options are required for that. Link master is also there. So here the thing is like that, the different OPC servers are available in the soft floor. So we collect the help of this advanced tag as well as something like with the help of the OPC UA client drivers. So we can collect all the server data into OPC UA client and advanced tag. With the help of the advanced tag, you map that particular tags. You can read and write from this any OPC server to the any OPC server data, and it is in the real manner we use the plugin for that particular things. Again, the same thing and same phenomena is also possible with the help of the link master. So in the link master, having a different OPC server is incorporated in different PLCs. So with the help of the link master, we can collect the data from the OPC server and either we can float it into the OPC client or something to for monitoring purpose, or link 0, link 1, link 2, like this. This is the type. Next slide, please, Nilesh. And the third solutions, it is the basically within that server. So this is the very popular things and very use case is available in the nowadays is like that, the routing the data between two PLCs, because the PLC having one PLC having a different protocols and another PLC have different protocols are there. So with the help of the OPC server within that server bridging, with the help of this advanced stack, we can mapping that particular thing, one read the data from one PLC and write it into the another PLC. So this is the OPC server within the server bridging is there. With the help of the advanced stack, this solution is possible. So next slide, please. Yes, so now basic thing is like that for the linking tag as well as link master. So link master we can more discuss about on the next session, but here why it is incorporated here is only for some differentiation between the link masters and link tags are there. The link master, that is communication must go outside the server. So within that server it is not possible. We require one server dedicated for the link master. Here all the communication happen is within that server only in the link tag plus link, that is for the advanced tag purpose. In the link master, that is built-in OPC DA functionality is there. So there is no need for, you can just drag and drop that server link and connection is with easy. Here the thing is like that OPC client driver is required with, and then you use the advanced tag. So this is the second something like a differentiations are there. Then in the link master, there is no mathematical logical functionality is there. Here, that is the advanced tag that all mathematical and logical functionality is available. That is the additional benefits for the linking tags. Advanced tag particular for the linking. Next slide, please. Now the second for the advanced tag, the second tag is the derived tag. So derived, basically the derive is some type of the mathematical and logical operation if requires, or something like some calculations are there, or some row value is coming from this CAP server and we have some calculations are there, mathematical calculation, logical operations using the existing tag in the server, equal to, greater than, less than, something like that. So expression can be created using the value of the quality of the system. You can use whatever the tag is required. You can use the value, either the quality of that system tags, or you can have some device tag is also, you can pair that particular things and calculated that thing to incorporate the logical operator in same way. So the derived tag, you can either it is one type of the calculation tag or mathematical calculation. Suppose for example, if you use some temperature is coming either particular in the Fahrenheit and you can monitor that thing into the Celsius. So you can use the subtraction for the mathematical and use this a very simple. So why this is used is here because in the ultimate goal to monitoring on the SCADA side or something like on the client side, suppose this functionality is not available, so you use this derived tag and monitor that tag into the client application. Same way some mathematical logical operation is supported by this derived tags also. So next slide please, Nilesh. The complex tag is also the very useful. So here the complex tag is used to unify the several tags. You can combine the several tags into the one complex in XML structure. So that is represented as a single output tag of the string data types. So here the examples like that, some string tag is also there, date and booleans, double and float is available. All these tags are there. So the combination of all these tags, you can have some bulk amount of this data. So it is very helpful if you would like to transfer the bulk amount of data only in one tag and send it the data to the transaction, you can transfer this to this. For example, suppose the populated the form with the string data in one operation. So it is the multiple tags of combination of the multiple tags, and tags type, any tag types is there, either is double, either string, or it is in the date format or in the float format, whatever the formats are there, you combine these tags into the single form. The separate tags in the server can be designed as to eliminate the elements of this complex tag. So this is basically the examples how you can use that particular complex tags. Next slide, please, Nilesh. Now, this is minimum and maximum tags is also the same thing as the whatever the tag value you define, and you can calculate what is my minimum value of that tag and what is the maximum value of that tag during the trigger interval. So that is possible with the help of the minimum and maximum tag. And using this tag, we can do the following like that. For the analysis purpose, it is very helpful because the minimum and maximum part size of the production line to ensure that the product are within the acceptable tolerance. So either you can use the minimum or the maximum tags, and you use that particular tags into the analysis purpose, and use these tags either for monitoring that the value of this tags minimum is this and maximum this for that particular interval. So you also define the interval with the help of the trigger tag conditions. Next slide, please, Nilesh. Here the average tag is also come under the advanced tags plugin. So average tag is used to calculate the average values to the selected tag during the trigger tag on the interval. So if you can calculate the average of whatever the values are continuously changes in that particular scan rate or particular temperature, which average is that. So based on this average, you can some analysis in the further is required. So it is very useful, particular for the advanced tags plugins. It is the average tag. Using this tag, we can do the following: find the average value of the selected tag over the day or the several days interval to create the timing benchmark. So it is for analysis purpose, it can be used, or you can have some type of the histo, something like that tag is to be used for either you can use interval for the day or the several days, something like that. You add that trigger and use this average tag for further analysis purpose. Next slide, please, Nilesh. This cumulative Oracle cumulative tags, it is also the useful for the sum of the different applications. So this tag enables you to determine the difference between the current value and the previous value. Suppose this tag, suppose whatever the values based on the scan time, whatever the current values are there, and the next value, next change is what is this. So you can difference that particular things and monitor that values accordingly. Suppose this tag is defined as Oracle is available from OPC client application. For examples like here, the cumulative value of the counter, suppose 0 to 100 counters are there, and we can calculate it particular if you use this counter as a cumulative tag. So here the samples like that in 10, 10.1, 10.2 and 10.3, the values of the samples is 5, 45, 95 and 4 is available here. Okay, now the thing is like that, if we use this tag as a cumulative tag, now the current value is the 5, then next value is the 45, then 5 minus 45 is there, Again, this value, it is the current value as well as minus this value. So this is basically the current value of that particular thing. So current value minus, it is difference between the current value and the previous value. Basically, it is the Oracle cumulative tags sometimes. So it is a different use case for this Oracle tags. Next slide, please. Now the second plugins available in the Kepware product or Kepware plugin is that for the SNMP. So basically, what is SNMP? So SNMP, as you know, or something like it is this protocol. One is the simple network management protocol. Nowadays is very useful, particular of the networking or network management system perspective. So if you measure the network healthiness or the switch healthiness, whatever the device on the network healthiness is require this SNMP, because if all the devices are SNMP enabled devices available in the market. So with the help of this SNMP agent plugin, we can access the whatever the automation devices are there in the soft floor. We can collect and merge this data, or we can collect that all this data automation devices on the IT administrator level. So SNMP is the simple network management protocol, and open and widely adopt the standards to connecting the network devices, and devices like available for UPS is also available, alarms and network switches is there. So this network switches and managed switches is there. Now this SNMP enables the network administrator to manage the network performance, find and solve the network problems, and plan for the network growth. So this is basically the features of that SNMP. This SNMP is the part of the TCP/IP suite, and it is maintained by the IETF, that is for the Internet Engineering Task Force. This is the background of the SNMP. How it is used, how it is can be applicable, or how we can SNMP agent work in Kepware in the next slides. Can you move the next slide, Nilesh? So in the Kepware, the SNMP agent plugin is enabled the most of the network management system to communicate with the automation device and the automation systems. Suppose it access the automation systems and device with the help of this SNMP agent plugin, monitor the network attached devices for the for condition, and avoid and remedy failure of the internal process, and fix the unexpected external event. So how we can use that particular things, or where we can use that thing. So here if IT or the network management system administrator wants to see the more detail about the data of the devices in automation perspective, although that device is not natively SNMP, with the help of SNMP agent, you can use or you can collect this data from the devices. For example, suppose Allen Bradley PLC is on the plant floor, and network management wants to read its timestamp registers, then this SNMP agent plugin is very useful. Can you move the next slide for the examples perspective? Yes, so this is the one of the examples that the giving the IT access to this PLC and device health. So here without SNMP or something like this, in the first one, only you use the PC health or something like network switch health, you can see like that without SNMP agent. And with the SNMP agent, network management system also be mapped this to the PLC's health measured in the network management system. So here, right, because the most of the industrial automation device and system do not support the information technology standards of SNMP. So there are limited means to identify this device and the system within the network management system application. So that is why the SNMP agent is required to measure the all this automation devices into the monitoring purpose or network healthiness purpose. Can you move to the next slide, please? So again, this is the SNMP agent features available is first is the provide the plant data to the network management system via MIBs. So MIB is basically the management information base. It is the definition file of all the switches, network switches is there. So right now is available in market, that is managed switch. Managed switch having some of the memories are there, having some MIBs, it is the private and public MIBs is there. So this via MIB about the device object tags, and it is the trap, that is unsolicited communications information for the devices. Second features is the gather the information from any of the protocols, whatever the protocol that we have discussed previously. So either Siemens or Allen Bradley, whatever the device, you can map this with the agent and measure the network analysis or to merge this into the network analysis purpose. And last, it is the leverage of the OPC communication to the KEPServerEx. So these are the basic features available for the SNMP agent plugins in the Kepware. So that's all from my side. So Prajwal, can you move into the Steam? Thank you.
Hi everybody, it's me again. So now I'm going to talk about the last section of the day. I'm going to talk about the link master and redundancy master. So let me start with the link master. So what is the link master? The link master is actually one of the few products that is both an OPC client and OPC server. I think as Vivek have talked about in the earlier sections, you can see that the functions are pretty similar to the tag link function in advanced tag. So it is kind of rather similar, and really the link master is kind of a subset of it in a way. The primary purpose of the link master is really to just bridge the different OPC servers and aggregate them into one. As Vivek has mentioned, because of the client server architecture, the server cannot talk to a server. So you need to have some sort of way to, if you want to pass the data from server to server, you need to kind of have a software that acts as a client to both sides and pass data across in a fast manner. So that really is some of the things that the link master can do, right? So the most important thing about the link master is that it's based on OPC DA. So for you to connect to any remote OPC DA server, you got to do your DCOM. So that's one key considerations that you have to deal with if you're looking to do the link master. So the link master, the first application is to act as an OPC bridge, which is kind of sending a data from server to server. So in this diagram, typically what you will see is that you will define one of the server as an input, and the data will flow in through the link master and goes out to the second server. So that's pretty much what we'll do. So you can see that in link master, the concept very much is dependent on what we call the input output IO kind of setup. And in the link master itself, literally there is a setting called input and output. So you will take the data point from one OPC server and put it onto the other side of the OPC server. I hope that I'm not confusing you. So you're taking tags from one OPC server and sending that data to another OPC server and another tag. Right, so that's typically the use case of the link master. The second way is to use it as a concentrator. So you can actually use link master to talk to various OPC server. And the link master itself also has a OPC server, so OPC DA server. So what this does is that if you what you can do is that you can use the link master to kind of establish a single connection to all the different OPC servers and broker that data out to third-party OPC client. So in a way, you're actually kind of optimizing and improving the performance by preventing situations where you have multiple scan rates coming in, and people are looking for all sorts of data, and just creating unnecessary traffic on the network. Right. So as a protocol translator, in the first use case, we talk about sending data from one OPC server to another OPC server, but you can also use it to send between tags in the same OPC server. So in this scenario, you can see that we are using a tag from Kepware and sending it to another tag also in Kepware. So what this does is that if your tags are in different devices, you are doing a protocol translation, because you're, for example, the tag A belongs to a Modbus device, and the tag B could be a Mitsubishi device, and you're just sending data from Modbus to Mitsubishi. So you're doing some sort of translation over there. Right, so this is, I'm going to do a demo on this, but essentially this is what we're talking about. You can choose the tags inside the UI and pass it to another tag. So that's really all for LinkMaster. It's a pretty straightforward product. And before I go into the redundancy master, I'm going to just do a quick demo on this. So over here, right, this software itself is pretty much LinkMaster. So I'm using the same VM that I was using earlier on. And what we can do, right, essentially is to browse the OPC servers that we have and look for tags to add in. So in the LinkMaster, you will first add a group, a link group, we call it, and then you can create a new link, right? I just call it link 0. Oh, wait, there's a better way. So what you can actually do, right, is just to, for example, I have a tag that is called random15. So the random15 tag is a tag that is generated through the simulator driver, and it just creates a random number between 1 to 5, right? And I'm going to throw it to this thing called the screen control tag in the Modbus TCP side. So I'm going to just take this and drag in input. So you can see it's defined as the input. And now the output is unassigned. And what I'm going to do is that I'm going to just look for the Modbus tag that I want to throw to, and I'm going to just throw it in. So you can see that once I throw it in and I haven't set it, once I save it and update the runtime, you will see that this will eventually, the data over here will be passed on to that data. Oh, I gotta start the runtime. See that? So once the thing is committed, you can see the data is being pushed on to from one tag in Kepware into another tag. So that's how the link master is typically used if, let's say, we are looking to use only the link function of the advanced tag. All right. So the next section that I will talk about will be the redundancy master. Okay. The redundancy master, when we talk about it, we need to identify, we need to recognize that there's different layers of redundancy. And it's important to understand that redundancy doesn't mean high availability. So you gotta, differentiate it pretty clearly. So on the client side, the clients can be set up to be a redundant pair and provide a failover condition. The most important thing to understand here is that Kepware is an OPC server. So the failover behavior really is not on the Kepware's portion. It has to be done on the client's portion. So if you have an OPC client that is connected to Kepware, the client itself must have the redundancy function built in, right? Because the server does nothing unless a client comes and talk to us and ask for data. So really the only thing that we can do really is to just have another node of Kepware with the exact same configuration. And on the device layer, that will be something that we can manage, because for Kepware, right, when we talk now to the device layer, we actually controls the driver, and that is the area that we can do some sort of redundancy using some features of Kepware. So the first feature will be the media level redundancy. I don't think I will go too deep into this because I think Vivek has mentioned this, right? So the redundancy plugin, as Vivek mentioned, it comes built in with drivers and they are free out of the box. It is available under the device and there will be a redundancy tab. And what it does is that it allows you to pair different devices as a redundant pair, or you could have a single device with two network connectivity, and you kind of need two of the network into the KEPServerEx. So typically you could have like a CPU with a dual net card. So two network card and they are on like a different ring network or something like that. And then you can use MLR to kind of redundant it. And this is actually how you would do it, right? You just need to click the device itself, right click properties it, and you should be able to see this screen appear, and just go under redundancy and choose the secondary path, right? You choose the secondary device. And once you've done that, you will notice that the icon will change. You can see that the icon is now like two devices. And on the client side, all you have to do is to subscribe to the primary. So when anything happens or the failover occurs, the failover will be transparent to the client. Right. So in terms of when to failover, we have different operating modes. The first one being switch on failure. So as long as we detect some form of error or communication to the device, we will do the failover. The second one will be to switch on trigger. So depends on, so this will be a more advanced kind of situation or conditional failover. You can either choose to failover when a tag doesn't change value or the quality swaps to bad, or you could be even when a value goes to 1 or something like that, right? So switch on trigger. And the last two are pretty much for, I would say, for troubleshooting. So you can force it to primary, force it to secondary, and so forth. So that's on the MLR feature, and it comes built into the driver. You don't have to buy anything, don't have to install anything. When you have Kepware, you connect to it, it's already there. The next one that we talk about will be the redundancy master. So the redundancy master is pretty much similar to Link Master in the sense that they are standalone products that you have to buy. However, the redundancy master was designed to provide redundancy capabilities into the client side. So remember that in the earlier sections, I talked about the redundancy master, or rather the client has to have that failover capability. So in the events that you do not have that failover capability, that's where you will use the redundancy master to provide that failover capability. So the most important thing to understand the redundancy master, that is exclusively OPC-DA. So you have, it was designed to provide failover, or rather failover capabilities to OPC-DA clients only. So if you have a UA client that you want to add, for some reason it doesn't have a failover situation, that's really, this product is not for you. So this product is really for the traditional OT kind of environment where we will use the redundancy master. So this will be a typical architecture, or rather a typical scenario that of a sample architecture. So you can see that in this screen, right, we have two computers. One of them with the DA client, and the other one with just an OPC server. Okay. So what happens is that when we identify a failover, when a failover condition is achieved, you will see that the connection will break, and redundancy master itself will then swap from this OPC server to that OPC server. So let me repeat again. So you can see that this will be the blue color line, which is the normal way. You can set the redundancy master to talk to this OPC server first, and when things happen, you can see that the redundancy master will then be aware that this connection is down, and it goes to the primary, the secondary DA server, which is located on the same PC where the redundancy master is. So if you look at this diagram, you should also be aware that because this is OPC-DA, the DCOM settings between PCA and PCB must be configured. If not, this system will not work. All right. So that's another consideration that you have to think through. And in terms of failover, the redundancy master have three different modes. Basically, the hot mode, warm mode, and cold mode. The hot mode, right, is the fastest failover in the sense that when you set a redundancy master to hot mode, it will then open connection to both OPC servers, the primary and the secondary, and data will be pulled actively, right? So the redundancy master will literally subscribe to it and get the data. On the warm mode, what it will do is that it will, on the secondary server, it will only subscribe but put the text as inactive. So in a way, the connection to get the data is being done halfway. So the OPC client, or rather the redundancy master, will open a connection to the secondary, and they will subscribe to the text that are required, but they put them in inactive mode. And last but not least, we have the cold mode, which is completely no connection at all. So during the failover, what will happen is that the redundancy master will then start the whole connection to the secondary upon detection of the failure of the primary node. So it will take the longest period of time, but in the sense, the benefit in the sense that they will not open any connection at all. Right. So in terms of failover condition, you can actually choose to monitor attack in the OPC server that you have. So for example, maybe on a situation where the data don't change, then you can use it to kind of set the failover condition. And the redundancy master actually comes built in with server diagnostics as well. So you can actually see the same, so the diagnostics in case you have issues on failover, you can backtrack on the logs and things like that. Another feature that comes with the redundancy master is email notification. So when the failover occurs, you can actually send out emails to notify you. So in cases where you want to do a UA client failover, really the solution that we will recommend, or rather what we have, is to just use Kepware and combine it with MLR to do what we call a UA tunneling. And that will allow you to have some form of redundancy capability to a UA client that doesn't have failover capability. So it's very straightforward. If you have a client which is based on OPC DA, and you need to give it redundancy capabilities, so you can go with LinkMaster. However, if you are using an OPC UA client that for some reason have no failover capabilities, what we recommend you to do is really just to use the UA client in KEPServerEx plus the MLR feature to kind of achieve that kind of redundant behavior. Yeah, with that, I think I've come to the end of my section.
Thank you, Steve. That was quite insightful. Okay, so folks, we've come towards the end of our discussion for today, and we have now enough time for some 15 minutes of Q&A sessions. So again, we have a lot of questions from the audiences, but I'll try to cover as many as I can during this short session. So the first one, Steve, I'd like you to take this is, what is the use case of a ODBC client driver?
Use case of an ODBC client driver, is that correct?
Yes.
Okay,
yes.
So to level everybody, this particular customer is talking about the ODBC client driver. It's not talking about the data logger. So the ODBC client driver is designed for you to connect to an ODBC compliant database and retrieve the data. The reason why we are doing that could be that you are interfacing with a third-party software, which has no way to get the data out beyond extracting from their database directly. So that will be a case where you want to do kind of a direct to SQL extraction of data. So that will be one use case. The other use case could be that you are doing stored procedures and you want to have Kepware trigger a bunch of stored procedures stored in the SQL server itself. So for example, maybe when the PLC goes down, you want Kepware to trigger a stored procedure, which can trigger, like data, other functions that you want the SQL database to do. So that's really the use case of the ODBC client driver.
Thank you, Steve. Vivek, can you take this one? Does auto demotion option configured for a project containing 150 channels with each channel having 150 tags, each will increase the performance of entire project? This seems to be a very project specific question, but
yes. Yes, it is a practical approach for the enable of auto demotion. So have some type of this performance based, it is very improvement. And use that particular properties of this tags or the devices. So yes, it is auto demotion enables facilities is very useful at the time of the performance of this values of these devices to connect
Okay.
that.
Okay, so all those who are interested to know more about auto demotion can get in touch with Vivek
Yes,
after this webinar, and Vivek will be able to help you with further features of this.
exactly.
Nilesh, can you take this up? Does the redundancy master support Windows Server 2016-2019?
Supported operating system,
Yeah.
redundancy master.
Mm-hmm.
I think 2016 is supported. 2016. There is as explained by Steve in his session, like redundancy master is the product we have, but in Kepware also you can have more or less similar facilities with media level redundancy. So you can also look for Kepware in case issues with operating system compatibility. So media level redundancy is also available for that functionality.
Okay, thank you, Nilesh. Steve, this one's for you. What is the minimum latency which can be configured for a device? For example, if a PLC can emit 5 millisecond data, can Kepware handle this? Steve, you there?
Muted, I think.
Sorry, I'm muted.
No problem.
So the
Yes.
answer is no, because the Kepware runs on general purpose OS, like our x86 machines or Windows platform. The system itself is not real time compared to say a PLC. A PLC runs on cycle time, right? CPU cycles. So no, we cannot do anything that is faster than 5 milliseconds. And to be honest, if you really need to, so really the question here is sometimes or most of the cases that we encounter do not require sampling at that kind of rate, because what you really need to determine is what is the fastest rate of change of data. And what you will do is you will sample twice at that rate. So if you're interested, you can look up for sampling theorem, and that really is some of the advice that we can give you. But as to your questions, no, we cannot do 5 millisecond data. The fastest I think we can do reasonably is around the range of 50 to 100 milliseconds.
Okay, thank you, Steve. Sheenu, can you take this one? For the same PLC, can we have multiple devices similar to the equipment that is connected? Or we need to have only one device containing the tags of all equipment connected to PLC?
Yeah, thanks, Rajul. What I interpret from in that question is that if you can configure multiple devices under each channel. That is right. Yes, you can configure. Yes, you can configure multiple devices, and the users can actually see the number of devices each driver is supported in the summary of each driver. So this can be seen under server configuration. If you have to click on help, and in the support information, you can select the driver, and you get the summary of the drive, what channels, how many channels it supports, and how many devices it supports, the driver supports.
Okay. Nilesh, the next one's for you. Can we use IoT gateway to send data to a MongoDB, let's say on AWS?
So MongoDB, as per my understanding, it supports REST API. So we can use basically IoT gateway REST agent to exchange data with MongoDB.
Yeah. Steve, feel free to comment to that one if you have some pointers.
Oh yeah,
so,
definitely REST. Definitely REST. We have done it before.
Okay. So yeah, so the participant who's asked this question, the answer is yes, and it has been done before. And Steve just confirmed on record, so you can play back the recording to him. Okay, so Steve, the next one's for you as well. Can you please explain connectivity and tag assignment in ThingWorx from Kepware?
I have no idea what this question is about. So I will assume that you are asking in the sense of connecting from ThingWorx to Kepware. So if that scenario, the connection from ThingWorx to Kepware is through the ThingWorx native connectivity. So really that's it. That's what it is. So you will enable that and you will connect it to that. And in terms of tag assignment, I will assume you're talking about binding the tags into the Thing property. So that is done automatically through the IDS Thing that was developed in the ThingWorx platform. So I will encourage you to just take a look at the guides that we have available from ThingWorx itself, and the whole process is pretty straightforward. There's no need for you to do any manual stuff. Once you enable the native connectivity, go into ThingWorx under the industrial thing, browse for the object, just select what you want and click bind, and that's it. The properties will be automatically loaded. So that's a very ThingWorx specific question. Yeah, so that's really.
Thank you, Steve. Okay, so the next one again, Steve, for you is for Influx database. You did not use data logger. How was it different from a data logger?
So in terms of InfluxDB, really the key reason is that the recommended approach is through REST. If you read through the documentation, the ODBC method, I believe is possible, but we have not tested it out on our end so far.
Vivek, can you mute yourself? I guess we have a static from your login. Thank you. Okay. So next question is for Sinu. Sinu, does it help? Does it need to purchase additional license for linking tag? Does advanced tags require separate license?
Yes, I think if you notice during the presentation, there are two methods of linking the tags. One is using the link master and other is advanced tag, and both link master is a separate product and advanced tag again is a plugin. So both has to be purchased separately. And if you need more detail in selecting this product, you can reach out to us. We'll share the required license based on your application.
The answer to that is yes, it is required, and then for more information, Shinu is available to answer your question. Nilesh, can you take this one up by unmuting? Does KEPServerEx support communication with Allen Bradley GuardLogix 5580 safety control?
Yes. Kepware supports 5580. So if you like go to Kepware site under like particular driver in supported devices, you can find out this 5580 is supported. Yes.
Okay. Steve, the next question is, does LinkMaster convert OPC DA to UA and vice versa?
No, it does not. If you want to convert it to DA to UA, just use the OPC DA client driver in Kepware, and the UA and the data. Once the data gets into Kepware, it will be automatically exposed out as the UA connection. And I just wanted to add on the specific question on the 5580. I think that you're talking about the GuardLogix 5580. So the GuardLogix 5580 is technically, we do not officially support it because we are not certified and designed for life safety control. However, you can connect it with the Allen Bradley Ethernet. So you can connect it, but if you want to, if you're coming in from the certification standpoint, we are not certified on that. So just be careful of that.
Okay, Nilesh, the next question for you. Can you please share the syntax of a UA address tag?
Okay. So as in demonstration, like I mentioned, basically OPC client driver uses syntax like your namespace index, then type and the value. So namespace index basically, but most of the time you'll be directly browsing to the OPC. So you will get this syntax automatically, but to just for understanding, the syntax will be like namespace index, then type of the like address, it will be mainly string, and then the value, whatever address value will be there. So we will get this address directly from the server while browsing the tags.
Okay, Vivek, can you take this one up for us, please? Does the link tag read and write to multiple tags from various different servers and PLC devices at the same time? And is there any delay that may cause during this process, or does it overload the network? It's a kind of longish question, but do you want me to repeat it for you?
No, I understand.
Okay. Okay.
But it is possible. But thing is like that, the server hardware or whatever how many tags you maybe link, or how many servers you were the multiple connections are there. So that is the basic part about the multiple link tag combination. So we require the exact applications about the multiple link tags. We conclude about the overloading of the system.
Okay. So the other question related to that was how many tags can be linked? Maximum limit of tags or devices?
Yes, that already answered that. That is the multiple tag you can link for that particular devices. So no limit for the link tags. But it is depends on the what are the specified limit of the. There is no any limitation of the tags, but the devices and channels limitations for that particular drivers are available in each driver's help. But there is no limitation about the tag.
Okay. Steve, I think the next questions you can take up. The question is which is the latest version of Link Master, and can it be used with Windows 10?
Okay, so for the Link Master, the latest version I believe is 2. Let me just double check right now.
Yeah,
because I have the exact number.
I think Steve, it's 3.0.
Is it 3.0?
94, yeah, 3.0.
Yeah, I would think so. So if you go to our My Kepware portal, you will be able to download the latest version. We typically only have the latest version up there. Let me just double check on that. And on the question on whether we can use on Windows 10, so unfortunately, I believe the Link Master is not stated to officially supported on Windows 10. So it's like redundancy master. We never, there's a certain list of supported OS, but the reason why we never state the operating systems that you like, say Windows 10 or things like that, is because we have not load tested against it. So the system will still work. You can still try to use the Link Master or the redundancy master on, say, server 2019 or 2016. It should still work. However, officially we have not tested it out. So, but if you run into any problems, feel free to drop an email and we will check it out for you. And for the question on the Link Master, the latest version, yes, is 3.0.94. So there's a couple of versions now. Yeah, but that is the latest version.
Okay, and the next question I'm taking is on data logger. Can we be able to log the data to Oracle database using data logger in Kepware?
I guess I'm thinking, so yes, you can use it on the Oracle database. Not a problem.
Oracle database. Okay. So ladies and gentlemen, we are bang on time. So I'm taking the last one, and the other questions that are still trickling in, we will try to respond to you in an offline chat, or we will try to email you. The last one that I'm taking in for today is, and Steve, you can answer this. What is the maximum advisable count of devices we can configure in a single channel?
Oh, that's a good question. So the maximum number of devices, the theoretical limit is determined by the protocol that you're using, and the number of devices that you can find, we can support per channel, is listed in our help documentation. So check out the help documentation to see how many maximum number of devices that we can configure. Having said that, the advised number of device depends on what kind of performance you can tolerate. Because as you stack devices down the channel, the communication cycle will go slower and slower and slower. It can go to a point where you realize that it just don't make sense. So you want to split into more channels. So So what you will typically do is that you will create a channel and you will create a bunch of devices. And what we encourage you to do is use the benchmarking tools that we have in Kepware to figure out, to see if this performance that based on your configuration is acceptable for your use case. If not, then we will recommend you to start to do the server optimization, which is just to multi-thread it. So reach out to Salah if let's say you need help on this, and I think they will be happy to help you with that.
Okay, thank you, Steve. Thank you for taking all the questions. It is nice to see that none of the questions were unanswered. So I guess that speaks about the confidence and knowledge of our speakers today. However, ladies and gentlemen, that's all that we could pack in for today's session. After this particular webinar, you will get an email, and also there's a link that we have shared where there's additional documents that you can download and use for your offline references. These are documents related to Kepware, data logger, and other details. You can obviously reach out to the teams that you are already in touch with. And there's also a short survey that you will receive after this webinar where we would like you to share your feedback. I wish you a very safe stay and have a pleasant evening ahead. Thank you, ladies and gentlemen. And a big round of thank you to all our lovely speakers who've taken out their crucial time out of their busy schedule, especially Steve. Thank you for sparing time today. Thank you.
Thank you.
Thank you all.